Hello and welcome to the all of IGCSE Add Maths video. So I'm going to take you through the 9 most important topics on the IGCSE 0606 additional mathematics course. And this really gives you a crash course of what you really need to know for the additional maths course. So number 1 is the factor and remainder theorem. Again, a real stalwart of the IGCSE Add Maths course. I'm going to go through 2 typical questions here that will really get you up to speed. Okay, so let's look at the factor theorem and remainder theorem. So we've got question 5 here. So the polynomial we're given here, p of x, is equal to ax cubed plus bx squared plus 6x plus 4. Where a and b are integers, that's important as we go through. And it's divisible by x minus 2. So I'm going to underline that. And also we're told here is when the derivative of p, so p dash of x, is divided by x plus 1, we are given a remainder of 7. So that's our key information. And then we need to find the value of a and b. Now, before I even start this kind of question, notice I've got 2 pieces of information, the divisibility here and the remainder given here. And I want to find 2 values. So I already know in my head here that it's going to be a simultaneous equation that comes out of what we're going to do. So keep that in mind as we work through. Right, let's look at the first point here, which is divisible by x minus 2. So if a polynomial, this thing here, is divisible by x minus 2, that means that p of 2, so you switch the sign here from minus 2 to plus 2, must be equal to 0, i.e. there's no remainder. So let's work this out. So p of 2, so wherever I see an x here, I'm going to put a 2. So a times 2 cubed, that's equal to 8a. Then b times 2 squared, that's equal to 4b. And then we got 6 times 2, that's equal to 12, plus 4 is equal to 16. So we're just substituting in x here for 2, and we're told from that statement I just said here that this is equal to 0. So that's our very first equation which we have generated so far. And now we're going to look at the second part of the question, which is when the derivative is divided by x plus 1, the remainder is minus 7. So let's do this in stages. First of all, I'm going to work out the derivative, differentiate this polynomial. Now remember the rules of differentiation. I will do this in more detail in a different part of this video. We bring the 3 to the front, so we get 3a, and then we reduce the index by 1, so we get x squared. And we do the same process here, so we bring the 2 to the front, so we get plus 2b, and then we reduce the index by 1, well that's just going to be x. Remember, x to the power of 1 is the same as x. If we're ever differentiating where this is with the power of 1, well we just take the number in front, the coefficients in front, so we get plus 6. Again, I'll go through that in more detail in other questions in the different parts of the video. And now what we're told here is that if it's divided by x plus 1, the remainder is minus 7. So remember, we switch the plus 1 to a minus 1. And the remainder, so what we get left over, is minus 7. So if we work this out, the derivative at x equals minus 1, we just put minus 1 into the expression here. Well, minus 1 squared, be very careful here, is equal to 1. So we get 3a. When x is minus 1 times 2b is minus 2b. And then we get plus 6 is equal to negative 7. So that's our second equation that we have generated like so. Now at this stage you can solve simultaneous equations by elimination and substitution. I'm going to take an elimination approach. You're going to see why as we go along. So first of all, what I'm going to do here is just change this equation slightly. So we've got 8a plus 4b. I'm going to bring the number to the right hand side. So I'm going to make this negative 16. And here I'm going to put the number on the right hand side, similar to how I did the previous step. So we get 3a minus 2b. Well, that's equal to negative 13. Remember, minus 7 minus 6 is equal to minus 13. Now, the reason I've gone down the elimination approach, and I spotted this when I was looking at the 2 equations, is notice that one can be changed very simply into getting the b's on its own. So all I need to do here is just times this equation by 2 here. So I'm going to keep the first equation the same. You could use row reduction or something else if you wanted to solve this, but elimination is your friend here. So 3a times 2, that's equal to 6a. 2 times minus 2b is minus 4b. And then 2 times minus 13 is minus 26. Now, because we've got it set up in this way, we can just add the equations together, and that will have the effect of eliminating b. So let's go through that carefully. First of all, 8a plus 6a is equal to 14a. 4b plus minus 4b, well, that's 0, so that's exactly what we wanted. And then finally here, minus 16 plus minus 26. So we're going to add the two negative numbers together, and that gives us minus 42. At this point, it's just now some straightforward equation solving. So we're going to divide by 14 on both sides, giving us a is equal to negative 3. Remember, solving any equations, you do those inverse operations. So we divide by 14 on both sides. Once we've got a as minus 3, we can substitute into any of the equations that we've seen so far. I think I'm going to choose this equation here at the top here. So sub in 1, just because the b is positive, that's the only thing I've kind of spotted there. So 8 lots of a, so 8 lots of minus 3, that's equal to minus 24, plus 4b is equal to minus 16. Then we're going to add 24 on both sides. That gives us 4b is equal to positive 8, and then b is equal to 2. And again, in any IGCSE exam, I'm just going to write the answers very clearly here for the examiner so they can't miss them. A is minus 3 and b is equal to 2. So making that really clear for the examiner. Those are my answers. Give me those 5 marks. Right, and on to part B, again, very typical. You want to use an answer from a previous part of the question here. Using your answers to part A, find the remainder when the double derivative, so p dash dash of x, is divided by x. Okay, so first of all, what I'm going to do is work out the double derivative. So I'm just going to do p dash dash of x here. So I'm going to take this expression and derive it again. Remember, we bring the 2 to the front, so we get 3 times 2 is 6. Reduce the index by 1, so we get 6ax. And then we differentiate this. Well, because we just got an x, we just take the coefficient in front. So we're going to have plus 2b. Now remember, we worked out a and b in the very last question here. So a is minus 3, b is equal to 2. So now I'm just going to pop those in at this point. Again, I could have done that earlier. So a is minus 3, 6 times minus 3 is minus 18. And 2 times 2 is equal to 4. And now it takes a little bit of understanding here. So if I divide through by x here, what happens is the remainder will be whatever's left over here. So this plus 4. So all we need to do, write down, is just that remainder is equal to 4. Because x goes into this exactly, what will be left over? Well, the plus 4 on the right-hand side. Okay, so you can check your answers here. Again, you can see exactly where we picked up the method marks. Again, at this stage here, this simultaneous equations, this can be done in a variety of different ways. Again, I try and look for the most efficient, the most clean way and avoid negatives because, yeah, that's where mistakes can be made. Right, on to another example question of this. So we're given another polynomial at this point, and we're told a and b are integers. Always good to know that because if you get a fractional answer, you've gone wrong somewhere, and then you need to go back and look at it. So here we're told it has a factor of x minus 2. So that's slightly different wording to what we've seen before. And then we're given our second piece of information, which is always needed if we're going to work out a and b here. So the first thing to consider is this first bit of information. It has a factor of x minus 2. What that means is that p of 2, remember we have to flip this sign here, the minus to a plus, is going to be equal to 0 because it divides incompletely. It's a factor. So what does that mean? Well, p of 2, we're going to pop in 2 wherever we see an x. So what do we get here? So 8 times 6 is 48, and 2 squared is 4, 4a plus 2b plus 2. And what we just said here, then we know that's equal to 0. So that's our first equation, which we'll tidy up a little bit later on, but just so that we've got that there. And now we're going to use the second piece of information, a little bit different to what we've seen before here. So first of all, I'm going to work out p of 1 and p of 0 separately. So wherever I see an x, I'm going to put a 1. So we get 6 plus a plus b plus 2. And then we're going to do p of 0 here. Well, that's really easy because all the terms of x disappear, and we're just left with 2. And now if we change this equation, so we take that p of 1 is equal to minus 2p of 0. Well, p of 1 is equal to this expression. Let's just tidy this up slightly. So 6 plus 2 is 8. So we get 8 plus a plus b equal to minus 2 lots of p0. So minus 2 times 2, that's equal to negative 4. So we've got our second equation here. And now it's that time where we need to generate our simultaneous equations. I'm going to do it very similarly to how I did the previous question here. So I'm going to bring all numbers to the right-hand side of the equation. So in this case here, this is going to be 4a plus 2b. 48 plus 2 is 50. We bring it to the other side, so that's going to be minus 50. So that's our first equation. Similar process here, so we have a plus b. And then we bring the 8 to the other side, so minus 4 minus 8 is minus 12. Again, set up in that nice way so we can solve it. In fact, we're going to do almost identical to what we did before here. We're going to take the bottom equation, we're going to times that by 2, so that gives us 2a plus 2b. Don't forget to times this by 2 as well, so minus 24. At this point, we can eliminate a variable by minusing the equations from each other. And if we do that process, we are going to get 2a here. The b's cancel. 2b minus 2b is 0. Minus 50 minus minus 24. So be careful here. So the calculation we're actually doing is minus 50 plus 24. Excuse me. So you have to be careful on that. That's going to give you minus 26. You can work backwards to check that's the case here. And then we just divide by 2, giving us a is equal to minus 13. And now we need to work out what b is. I think this equation here is the easiest to use because there's very little to work with. So sub in 1, so that means a plus b, so minus 13 plus b is equal to minus 12. Therefore b must be equal to positive 1. So our answers here, again, I'll be nice and clear for the examiner. A is minus 13 and B is equal to 1. Just like that. And now, again, a follow-up question, which is very typical here. Again, a little bit more complicated than what we've seen before. So using your values of A and B, find the remainder when P of X is divided by 2x minus 1. Okay, so first of all, we need to write in what P of X is now. Now we know that A is minus 13, B is equal to positive 1. That means then our polynomial, our cubic, is 6x cubed. A is minus 13, so minus 13 x squared plus x plus 2. Right, and we want to find the remainder when it's divided. So as soon as you see this kind of question, it's a process that I know my students absolutely love here. This is going to be some algebraic long division or synthetic division. So let's get ready for this. So we're going to have 2x minus 1 here, and we're just going to, by brute force, divide through. So we get 6x cubed. Now remember, if there was an x term, you'd have to put a 0x, so remember that. Again, not in this question, but if you do more complicated questions, that is going to be the case. So the process goes as follows here. So what do we do to 2x here to get to 6x cubed? Well, we multiply it by 3x squared. Again, you can always check backwards, make sure that's the case. If we do that, well, we get 6x cubed, which is what we wanted when we subtract a bit later on. And then minus 1 times 3x squared is minus 3x squared. Now we're going to subtract one from the other. The whole point of this process is that first term does disappear. But be careful with the next part here, which is minus 13x squared minus 3x squared. Well, remember, two minuses make a plus next to each other. So that's going to give us minus 10x squared. Be very, very careful when you do this. So we're going to drop the plus x down here and then do the same process again. So what do we do to 2x to get to minus 10x squared? Well, we need a minus, we need a 5, and we need an x as well. Again, check backwards as you go through. So minus 5x times 2x is minus 10x squared. minus 1 times minus 5x is plus 5x. Again, be careful with negatives as you go through. At this point, we are going to take one away from the other. Lots of minuses, but that's how it is. Minus 10x squared minus minus 10x squared, well, it makes a plus, so it's going to cancel. And then x minus 5x is minus 4x. We drop down the 2. And then what do you do to 2x to get to minus 4x? Well, we need a minus 2. And then work through the same process. So this gives us minus 4x. Minus 1 times minus 2 is plus 2. Ah, fantastic. Because when we minus them from each other, we get 0. Notice they cancel each other out. So our remainder here is simply what we worked out right at the end. So the remainder is 0. And on top of that, that also means that this is a factor. And that's important for the next question because we need to factorize p of x completely. So first of all, we know that this can be written as 2x minus 1 and then 3x squared minus 5x minus 2, because these two things multiply to give me that cubic underneath. Now, you can obviously factorize this actually fairly straightforwardly using some mental methods, but this is the key thing with these Add Maths questions. Go back, notice we are told that this is also a factor, x minus 2. So that's really going to help us when we actually factorize this bigger bracket over here, because we know that x minus 2 is also a factor. And so all we need to do now is kind of work backwards and think about what goes in this third bracket to generate this. Well, we need a 3x to start with, because 3x times x is 3x squared. It's the only way we can do that. And then we need minus 2 times something to give us minus 2. Well, the only thing that can be is plus 1. Again, if you're not sure about that process, what you would do here is just expand this bracket out just normally and then guarantee that you get back to this answer up the top here, which is 3x squared minus 5x minus 2. So always worth double checking these things because you can always work backwards through the problem and then guarantee you've got these 2 marks or the 4 marks all together for part B. Okay, so you can check your answers here. So have a look through, and if you're finding the video really useful for you so far, then please do give it a like. It goes a long way to spreading this information to as many Add Maths students as possible, and hopefully it will help them for their exams as well as yourself as well. And number 2 is quadratics, but I'm also going to put in some indices here as well, as these are often quite linked when you look at exponential equations using quadratics. Okay, and now we're going to be looking at some quadratics with some indices work in there as well. So you get to cover 2 for 1 in this particular section. So we're given this very horrible expression, q to the power of minus 2 root pr over the cube root of r brackets pq to the power of minus 3. And we need to get it in this particular form, p to the power of a, q to the power of b, r to the power of c. And we want to find out what a, b, and c are in this particular question. So the way I kind of approach these questions is put them all into index form. Now, what do I mean by this? Well, q to the power of minus 2 is already in index form. It's something to the power of something. But notice this root PR is not in that form yet. So what I'm going to do here is put PR to the power of a half. Remember, a root, like a standard square root, is to the power of a half. The cube root of r, we want to write that in index notation, which is to the power of a third. So you need to know these off by heart to make your life a little bit easier. And pq to the power of minus 3, well, that's kind of already in that kind of index form. My next stage is to expand out any brackets. So what do I mean by this? Well, pr to the power of a half can be represented as p to the power of a half r to the power of a half. And likewise down the bottom, we have r to the power of a third, and this minus 3 applies to both. So we get p to the power of minus 3, and then q to the power of minus 3. Now, to simplify this down easily, we're going to put the letters in order. I tend to use alphabetical, but as long as they're in order, that's what's important. So we have p to the power of a half, q to the power of minus 2, r to the power of a half, and then putting this in order, we get p to the power of minus 3, and q also to the power of minus 3, and then r to the power of a third. At this point, now I can simplify the p, the q, and the r separately, which is the important part here. So let's look at the first part of the question. So here we have p to the power of a half divided by p to the power of minus 3. Well, that's the same as p to the power of a half plus 3. We do the same now with the next part, so we get q to the power of minus 2 plus 3, and then r to the power of a half minus a third. Now, if you're comfortable with this topic, you don't need to break it down in this way. If you're starting this relatively new, then this is a good approach to take. So for this one here, well, we have a half plus 3. Well, that's 3.5, which, remember, 3.5, if I write this separately, that can be written as 7/2. I generally use improper fractions with this kind of question. So we can write that as 7/2. Minus 2 plus 3, well, that's just equal to 1. And then a half minus a third. And you can do this mentally if you're happy with that. If not, then we just convert both to out of 6. So 3/6 minus 2/6. And that gives us 1/6. So a little bit of fraction work here as well, which you should be comfortable with. Notice we've now got it in the form that they wanted, so let me just highlight that. So we have our A, which is up here, we have our B, which is here, and we have our C, which is here. So just to make it very clear to the examiner here, what we'll do is then A is equal to 7/2, B is equal to 1, and then C is equal to 1/6. So very clear exactly what the answers are. Now we're going to move into some quadratics, and probably the first question to ask here is, how do I even know that this is a quadratic? Well, the first thing that comes to mind here is you look at the 4/5 and 2/5 and notice you can multiply one by 2 to get the other, and that's the first thing that comes to mind. We've also got 3 terms equal to 0, so lots of things are ringing in my mind thinking, quadratics could be involved. Now, how do we put this in a form that we can actually work with quadratics? Well, we're going to use some fraction skills. So what I'm going to do is I'm going to change this 4/5 to 2/5 all squared, so unsimplify it essentially. Now notice you can check that, 2/5 times 2, that's equal to 4/5. So I haven't changed anything here. I'm going to leave this the same for the moment, and then put this 5 equal to 0. Now, what I'm going to do, and you can do this directly if you're happy with it, but I'm going to use a substitution. So I'm going to let y be equal to x to the power of 2/5. You're thinking, why would you even want to do that? Well, let's see what comes out. Well, if we substitute it in, 3 stays the same. Remember, this thing in the bracket here is equal to y, so we get y squared. Very nice. Then we get minus 8y plus 5 is equal to 0. And by using this substitution, which is a really crucial technique at Add Maths, also at A-level and IB, we get a quadratic that we can solve. Now at Add Maths level, the generally way I teach this is that we get 3y and y to start with, because it's the only way we can get 3y squared. We want two numbers that multiply to give us 5. They both have to be negative because we've got a negative term there, and we want to get 8. And I think if we put minus 5 and minus 1, again, what I would do here is check the cross terms. So check this multiplication and check this multiplication. Well, minus 1 times 3y is minus 3y. Minus 5 times y is minus 5y. That's equal to minus 8y. Yep, that's exactly what we need. And now we solve this in our usual quadratic methods. So either the first bracket, so either 3y minus 5 is equal to 0, which means then that y needs to be equal to 5/3, or y minus 1 is 0, therefore y is equal to 1. And now we do a back substitution, so now I'm going to replace that y with the x to the power of 2/5, giving us 5/3 there, and then x to the power of 2/5 is equal to 1. Okay, so the only way that this can be true is that something is equal to 1, therefore x itself must be equal to 1, so that's quite an easy one to do here. And with this one here, what we can do is actually raise both sides. So the way I would try and go and solve this is I'm going to take both sides and raise to the power of 5 over 2. So let me just write that down. Because notice if I raise both sides to 5 over 2, these two things multiplied, they cancel, giving me just x. And now I need to use my calculator to work out the right-hand side. Okay, so we're going to pop in 5 over 3. Better put this in brackets, like so, and then we want to put this to the power of, okay, we can write this as a fraction or decimal, it doesn't really matter. So we get 5, there we are, 5 over 2. Press the answer button, and then we get our answer of 3.586. 586, dot, 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 and then rounded to 3 significant figures. That's 3.59 to 3SF. Okay, so I'm just going to put my answers very clearly for the examiner. So the two answers are x equals to 1. Again, you could also work this out by raising both sides to the power of 5 over 2. That also works. Or it's equal to 3.59, like so. And you can check the answers there. Again, this is where these videos really do come in handy because the mark scheme doesn't really give you too much here. But if you go through this video, go through these examples carefully, you'll have a good understanding of at least 50-60% of the entire paper. Right, let's look at another example. So very similar, this one, slight twist at the end, which we'll see in a moment. So again, same procedure here. We want to write this out all in index notation and then put it in order and then simplify. So the cube root of xy, so we can write that as xy to the power of a third, and then we've got zy squared, which we could multiply out immediately, but I'm just going to take this in steps. We've got xz to the power of minus 3. Root of z is equal to z to the power of a half. Then we're going to multiply these out. So we've got x to the power of a third. We've got y to the power of a third. We've got a z squared and a y squared. And then we've got a x to the power of minus 3, a z to the power of minus 3, and a z to the power of a half. Now this is a slightly different style of question because we can actually do some simplifying in the numerator and denominator first. So x to the power of a third stays where it is. We've got y to the power of a third times y squared. Well, that's y to the power of 2 and 1/3, which is equal to, so and I'd always just write this out as you go along. So 2 and 1/3, that's equal to 7 over 3. So we get 7 over 3, z squared stays the same. And now we want this in order, so x to the power of minus 3, that's fine. I've just got z, so z to the power of minus 3 plus a half, it's minus 2.5. And that's equal to minus 5 over 2. So z to the power of minus 5 over 2. Okay, and now we start simplifying. So we've got a third, x to the power of a third minus 3, so plus 3. So x to the power of 3 and a third, which is 10 over 3. You always do these little notes as you go along. There's no reason why not. Y stays the same, so we're happy with that. That's 7 over 3. And then we've got 2 minus 5 over 2. So that's equal to 4.5. 4.5, that's equal to 9 over 2. So we pop that there as 9 over 2. And again, make it very clear to the examiner. So that A is equal to 10 over 3. B is equal to 7 over 3. And C, make sure you use the letters from here, is equal to 9 over 2. And we've got all our answers there. And now we're going to go into some more quadratic solving, slight twist on what we've looked at so far. We need to solve this equation. Now this probably is a bit more straightforwardly a quadratic, because notice you've got a 2 to the power of p, 2 to the power of 2p, so you know there's some quadraticness going on in this question. But notice you've got 2p plus 1, which is kind of irritating. So we need to do a little bit of what I like to call jiggery-pokery to get this in a form that we can actually work with. Now the first thing I'm going to do here is I'm going to change this slightly. So I'm going to write this as 2 to the power of 2p times, I'm going to use a dot for times here, 2 to the power of 1. Notice if you're adding indices, it's the same as multiplying them together. And then we're going to leave this alone for the time being. And now let's think about what I've done over here. So notice this is just timesing essentially by 2, because 2 to the power of 1 is 2. So I can actually bring this part and this part together. So 2 times 5 is just 10. So we get 10, 2 to the power of 2p. Probably see what I'm up to here. Well, I'm going to put in my sneaky substitution. And then to make this really clear exactly how I'm going to substitute, I'm going to do the same thing I did before here, which is I'm going to rewrite this as 2 to the power of p all squared. Remember, p times 2 is just 2p. So I am allowed to use index laws to write this out. Once I've got this, now I can do a nice substitution. So I'm going to let y equal the bracket, so y is equal to 2 to the power of p, and it's going to be very similar to how we did it before. So we get 10y squared minus 17y plus 3 is equal to 0. At this point, this is slightly harder to factorize, because notice there are two options we've got for our bracket here, which is I could put 10y and y, or I could put 5y and 2y. From my experience, they generally usually do 5y and 2y in exams, generally speaking. But if this wasn't to work for whatever reason, I could check 10y and y as well. Luckily, I've got a 3 here, which means there's only two numbers that multiply to give me 3, which is 1 and 3, and they both need to be negative to give me a negative 17y, or negative thing of y. And now it's just about putting the numbers in the right place. I'm going to put a 3 here and a 1 here. Check those cross terms if you're not happy with that. So 5y times minus 3 is minus 15y, minus 1 times 2y is minus 2y, minus 15y minus 2y is minus 17y. All good. At this point, then we can solve this quadratic. So either 5y minus 1 is 0, which gives us y is equal to 1/5, or 0.2, whichever you prefer, or 2y minus 3 is equal to 0, so therefore y is equal to 3/2, or 1.5. At this point, so let me just pop this down here, make it nice and neat, is I'm going to back substitute now. So wherever I see a y, I'm going to put the 2 to the power of p. So I get 2 to the power of p is equal to 0.2, or 2 to the power of p is equal to 1.5. Excuse me. So at this point, we're going to need to solve this. Unfortunately, it's values that don't work out very nicely, so I'm going to have to use some logs. Now, I'm just going to use the standard process for logs. You could just write this directly as a log statement. I'm going to assume you've only got log base 10 for these particular questions. So if I take 2 power of p is equal to 0.2, I'm going to take logs of both sides. Doesn't matter what log. I'm going to take log 2 to the power of p is equal to log 0.2. The reason we like to use logs here is I can take the p and bring it to the back. So I get p log 2 is equal to log 0.2. And then what's the opposite of timesing by log 2? Well, dividing. So we get p is equal to log 0.2 divided by log 2. And you can do a very similar process for this one here as well. I'm not going to write out all the steps, but it would become log 1.5 divided by log 2. Only at this point do I need my calculator, so let's work out the final answers for p. Okay, so always good to know where your log button on whichever calculator you're using here. So I've got my log button just here, so control here. Again, I don't need to worry about bases for this particular question. So I've got 0.2 there, and then I want log 2. That's going to give me my first answer here of minus 2.32. So minus 2.32. And then this next one, so we're going to do the same thing again here. Log 1.5. Again, you can use any calculator. I tend to use calculator for IB, so I'm going to stick to using this. You've got Casio, that's also fine. You'll see some of my videos, I also use the Casio CG52. So we've got log 1.5 over log 2, and we get 0.585. Again, make sure you're rounding to 3SF, so be careful. You don't want to lose a mark just for incorrectly rounding. So we've got two answers here. P is equal to minus 2.32 and 0.585. So you can check the answers on this particular section of the video, where I've kind of combined indices and quadratics into one particular section. And this kind of question comes up very, very often on the Add Maths papers. And number 3 is vectors. So I'm going to show you two typical questions, one more on the vector algebra side, and then one using position vectors, unit vectors, and some problem solving as well. Okay, and on to the Add Maths vectors section. So we have a quadrilateral OABC here, where OA is the vector OA, the vector OB makes sense, is going to be B. So remember, this vector OB goes all the way across, which is not very clear from the diagram, and then OC is equal to C. And we're told that OB and AC intersect at this point P here in the middle of the shape, or in the center of the shape, where the AP to PC, so the ratio of that is 3:2, which we're going to use in a moment. Now we need to find the vector OP in terms of A and C. We can't go directly, we'll need to go around. So the first thing that we're going to work out here is the vector A to C. So we're going to work out the indirect route to go from A to C. Well, to go from A to C, we go from A to O and then O to C. So I'm going to write that in nice and clearly. So A to O and O to C. Well, what's that equal to? Well, the vector A to O, we're going against the arrow, so we're not going to go plus A, but we're going to go minus A, and then going from O to C, well, that's just following the vector C. So the vector AC, let's go from A to C, in that direction, we're going to take the long route, A to O, and then we're going to go O to C. However, we're not interested in that vector, we are interested in the vector AP. Well, notice the vector AP, it's in the ratio of 3:2. So in other words, the line is split into 3/5 and 2/5. Okay, now the way I work that out, well, 3 plus 2 is 5. That's going to be my denominator. And then it's split in 3/5 and 2/5. So what does that mean for this question? Well, AP is going to be 3/5 of the vector we just worked out, which is AC. So the vector AP will equal 3/5 of AC, so 3/5 of minus A plus C. And now we've got all the basics here to work out what we want, which is the vector OP. So to go from O to P, we're going to go from O to A, so we're going to follow this line up to here, and then we're going to go from A to P, going in these directions. So the vector OP is the same as O to A, and then we're going to go A to P. Notice how I've broken down this question to make this easier to work out. Well, the vector OA, we're told in the question here, is just equal to A, and then AP is what we worked out here, so 3/5 of minus A plus C. So now we're just going to expand brackets and simplify. So we're going to use the hook. So we're going to leave the A alone for the time being. 3/5 times minus A is just minus 3/5 A. Then 3/5 times C is just plus 3/5 C. And now we can collect like terms here. So we've got 1A here. We're going to minus 3/5 from it. Remember, 1 minus 3/5. That's the same as saying 5 over 5, because 1 is just 5/5, minus 3/5, and that's going to be equal to 2/5. So we get our final answer here of 2/5 A plus 3/5 C. And I always do a double check at the end. Does that make sense? Where P is, there'll be 2/5 of this and 3/5 of that. Well, that kind of makes sense. We're definitely going in the right direction. So we've got our final answer, 2/5 A plus 3/5 C. Now we're given some extra information in this part of the question that the ratio OP to BP is 2 to 3. So remember, this is 2/5 and 3/5. And now we need to show this equation coming from nowhere. Well, let's go back to the question. Remember, I said this right at the start, and I'll do this in a different color. This vector B goes all the way across. So this vector represents OB. So if we want to represent OP in terms of B, well, OP, well, that is going to be 2/5 of the line. This part here is 2/5 of the whole vector that goes across B. Now notice we've now created two expressions for OP. We've created one in terms of B, which is OP is 2/5 B, and we've got what we worked out before, which is also equal to OP. So if that is true, the two things must be equal to each other. So we take what I did in green here, so 2/5 of B, and that's equal to this box here, which is 2/5 of A plus 3/5 of C. Now at this point, we want to achieve this equation here. We can do this really, really easily by just multiplying by 5 on both sides. If I do this, well, this cancels, so we're left with just 2b. And by timesing by 5 both of these expressions, the 5 cancel, leaving us then 2a and 3c. And to make it look exactly like I want here, well, I'm just going to switch around the a and c to give me 3c plus 2a. And I get exactly what the examiner wants here. So you can check your answers here and you can see where I pick up those B marks and M marks, as well as the accuracy marks at the end of the question. Right, onto a more complicated style question, and this really fits in well with A-level maths or IB maths. This is good training for you when you go into those courses. So relative to an origin O, we've got some position vectors here of A, B, C, D, and we've got the various different expressions. Remember these vectors here, the top number tells you to go left and right, and the bottom number tells you to go up or down. If it's negative, it tells you left and down. If it's positive, it tells you right and upwards. And before I even do this question, I would certainly do a diagram here to represent the situation. So I'm going to spend a bit of time here just visualizing what's happening. So when we do the A, B, C parts of the question, it's going to make it much more easy. So let's put some vectors in here. So first of all, we've got the vector OA. Remember, we're always starting at the origin because we're doing position vectors here. So we're going to go 6 minus 5. So that's 6 to the right and 5 downwards. Again, not to scale in the slightest here, but just to give you an idea of what's going on. So this is going to be the vector A here. We've got OB, which is 10, 3, so 10 along and 3 upwards. So we're going to pop that over here. So that's going to be our vector B. And make sure we put the arrows in as well. OC we don't know. We'll come back to that for later questions. And then OD is equal to 12, 7. So that's going to be even further along and then further upwards. So that's going to be roughly here, like so. And let's just mark that in as D. Right, and now we need to find first of all we need to find the vector and then the unit vector in the direction of AB. So let's label those two things, unit vector and AB. Well, first of all, I'm going to work out the vector AB. Now there is a formula to do this. It's just B minus A, or in this case OB minus OA, which can also be expressed as B minus A. But let me show you where that comes from. So I want to work out the vector AB. Well, here's A and here's B. So I want to go from here to here. And in order to work that vector, we use what we did in the previous question, which is I'm going to take the long way round. I'm going to go against the arrow, so that's minus A, and then plus B, which is the same as B minus A. So you want to visualize what's going on here, working out this vector. Well, this is what's going on here. We're essentially looking for this vector AB. Now, if we do the numbers here, well, B is equal to 10, 3. OA is equal to 6 minus 5. And so we're going to do 10 minus 6, which is equal to 4. 3 minus minus 5, 2 minuses make a plus. 3 plus 5 is equal to 8. So that's the vector AB, but I want the unit vector instead. So there is a formula to work out the unit vector. So in order to work out the unit vector here, all I need to do, and we can represent this with a circumflex, is 1 over the modulus of this vector, and then times the initial vector AB, which is 4, 8. Now, how do we work out the modulus of a vector? Let me pop this down here. We're just going to use Pythagoras on this. So we're just going to take these numbers and put this into Pythagoras. So 4 squared plus 8 squared. Again, you can use a calculator if you so wish, but we're going to do 16 plus 64, and that's equal to root 80. So then our unit vector here is just going to be 1 over root 80. Again, you could simplify this, and then the vector we worked out before, which is 4, 8. For the examiner, I would certainly just underline this, making this really, really, really clear that that is my final answer for this question. Now, on to point B. Well, we're told here that the point A is the midpoint of BC, and then we need to find the value of x and y, so this value here. Well, let's think about this for a moment. So we've got our vector 10, or that's part of the vector 10 here, and we know that 6 is in the middle, because we're told that from the question, and then we want to work out what x is. So what do I do to 10 to get to 6? Well, that gap in between is minus 4, so then this gap also needs to be minus 4 as well. By doing this process, you can see very clearly here that then in order for this to be the midpoint 6, then I just need to do 6 minus 4, which is equal to 2. Therefore, x is 2. And I can do the same with the y components as well. So I've got 3 here. I know the midpoint is minus 5. So just here, the midpoint. And I know this is here y. What do I do to 3 to get to minus 5? Well, minus 8. So we're going to have the minus 8 here as well. And be careful here. Minus 5 minus 8. That's going to be equal to minus 13. Therefore, y is equal to minus 13. I'm just going to underline those to make those very clear. So our vector OC is going to be 2 minus 13, like so. Okay, so now a more unfamiliar question on vectors. So the point E lies on OD, so it lies on this particular vector, such that OE to OD is in the ratio 1 to 1 plus lambda, which we're going to rewrite in a moment here. And then we need to find the value of lambda such that BE is parallel to the x-axis. So we need to break this down first of all. And one thing I'm going to do is just change the ratio here slightly. So I'm going to divide both sides by 1 plus lambda. This is going to be a bit helpful a bit later on. Again, we're allowed to do this because we're doing the same to both sides. If we do this, we get the ratio 1 plus 1 plus lambda. And these two things cancel, giving us 1. So what this shows is that OE is going to be smaller. So for example, when lambda is 3, for example, then it's going to be the ratio 1/4 to 1. So by doing this process, I've just shown very clearly here that this vector OE, which we're considering here, so to try and find this point E, is going to be somewhere along this vector here. And if we take the second bit of information, we want BE to be parallel to the x-axis. So what that means is we're looking for a point here somewhere such that it's parallel to vector B, i.e. I can draw a straight line across and it's parallel. So that means then that we need to have the same y coordinate as B, so specifically the 3 here. So we're going to piece this all together and then we're going to work out the answer. So therefore, OE, if I write this as a vector to OE, it's going to be 1 plus 1 plus lambda, so a scalar multiple of OD. Now we know what OD is from the question. We know that's equal to 12, 7. We also know it needs to be parallel to the BE needs to be parallel to the x-axis. Basically what that means is it needs to have the y component of it equal to 3. Well, what we can do here is just multiply through by this scalar. So 12 times 1 plus lambda is 12 over 1 plus lambda, and 7 times 1 plus lambda is 7 over 1 plus lambda. So in order for BE to be parallel, this here, the y component, needs to be equal to the y component of OB. Therefore, we can set up a very straightforward equation here of 7 over 1 plus lambda is equal to 3, the y component from here. Once we've got that, then we can just make lambda the subject. I'm going to do that by multiplying by 1 plus lambda on both sides. This cancels, giving me just 7 equals 3, open brackets, 1 plus lambda. And then we can multiply out the brackets using the hook. So we get 3 plus 3 lambda. Therefore, 3 lambda must be equal to 4. And so lambda must equal 4/3 in order for BE. So if I go back here, we want this to be point E. This is point B. It's parallel to the x-axis. You can see the x-axis and this line will never ever meet. Again, you can check the answer here and go through the solutions. This is 10A and 10B. And then this is 10C. I've taken this approach at the top. I think this is the most straightforward, but there is an alternative approach you can also take down below. So this is the vector section of the Add Maths video, and then we're going to move on to the next topic. And number 4 is trig equations and trig identities. So this is a bigger section because it's really important to understand. There's a lot of very quick nuances you have to be really careful about. Okay, and on to the trig equations section of the video. Often students find this topic particularly tricky on Add Maths, so do pay attention very carefully, and we will be working between radians and degrees, so make sure you can change your calculator between them. Right, first of all, we need to solve this following equation. So sine alpha cosec squared alpha plus cos alpha sec squared alpha equals 0. And we have our domain between minus pi and pi. So that's minus 180 degrees and 180 degrees. And before we start, we need to know what sec and cosec stand for. So remember, sec of alpha, again, this is equal to 1 over cos alpha. And then cosec of alpha is equal to 1 over sine alpha. These are key things that you need to know. Again, if you're not sure about these, then do please look them up as we go through. They're going to be very helpful for you as we go through. So the first thing I'm going to do here, using these conversions, is changing cosec and sec into sine and cos. Now, how do I do that? Well, I'm going to have sine alpha. Now we've got cosec squared alpha. Remember, cosec alpha is 1 over sine alpha. So this will then become 1 over sine squared alpha. And we're going to do the same with this over here. So we've got cos alpha. And then remember, sec squared alpha, that's going to be equal to 1 over cos squared alpha. So I'm going to use the dot here for multiplying. So 1 over cos squared alpha. And that's equal to 0. Now the reason you can do this and it's helpful is that we can cancel through a sine alpha. This is we cancel here, and then we can take out 1 from here, and we can do the same over here. So remember, a cos alpha cancels with a cos alpha in the denominator. That's going to leave us then with 1 over sine alpha plus 1 over cosine alpha is equal to 0. Now, generally when I have two fractions in a trig identity style question, I generally want to get one fraction out of it. So the way I'm going to do that here is create a common denominator of sine alpha and cos alpha. Okay, and this is the way you would do, for example, we've had 1/4 plus 1/3, then we want to write this out of 12. And the way that we create the numerator is we do 1 times 3, which is 3, and then 1 times 4, which is 4, and add them together at the top. I'm going to do exactly the same process here. So 1 times cos alpha is just cos alpha. 1 times sine alpha is just sine alpha. So it looks like I'm making it more complicated here, but now I'm going to exploit the right-hand side, which is if any fraction is equal to 0, then we know the numerator has to be 0. Therefore, I can say then that cos alpha plus sine alpha is equal to 0. So I am making progress in exploiting that right hand side. I notice we're equal to 0, so that gives me a bit more flexibility in the algebra I can do. At this point, I'm going to minus cos alpha from both sides, so we get sine alpha is equal to minus cos alpha. And now I'm going to divide both sides here by cos alpha. So a little bit, as I like to call here, jiggery pokery, to get it in a form that's nice. So if we divide through by this, we get sine alpha over cos alpha, and these are going to cancel, leaving me with just -1. And the reason I did this is another identity you need to be aware of. Sine alpha over cos alpha is equal, or always equal to tan alpha. Again, another key fact that you do need to know, and then we can just change this, then equal tan alpha is equal to -1. Right, so now finally we can go about solving for alpha. Notice our range here between -pi and pi. The first thing I'm going to do here is work out the first answer by doing tan inverse on both sides. Now you might know your exact values, in which case this is going to speed up this process. But if you're not entirely sure, the first answer, you have to be careful, there's going to be more than one answer with these trig problems, is we're going to work out the inverse tan of -1, remembering we're in radians. So make sure your calculator says rad or r at the top, otherwise bad things are certainly going to happen. And so what we want to do here is tan inverse of -1, and we get this as -0.785. Now you're absolutely fine in working with decimals here. If I show you the mark scheme here, just quickly, you'll see that you can write this in decimals, but you could also write this as exact value as -pi/4. I'm going to stick to decimals since my calculator gave me this, so -0.785. Again, this is to 3SF. However, we do have to be careful because tan does repeat every 180 degrees or pi radians. So there is an alternative answer, and the way that we calculate this is we add pi to 0.785. Remember, if you think about a tan graph, I'll do a very quick sketch here, it repeats every pi radians. So we've worked out one of the answers, so one of the answers down here, but we also need to work out this answer here as well. Let me do this in a slightly different color. So we worked out one down here, but we need this one. And the way that we do that is just add pi to our existing answer. So if I go back to our calculator, all I do is take my answer, add on pi, there's pi, and then we get our second answer, which is 2.36 radians. So 2.36, also to 3SF. You can put the radian sign here, which is this small c. Well, it looks like a small c. It actually isn't a small c. It's actually the arc of a sector, but you can use that symbol to represent that it's radians as well. So you can check the answers here. We've just done the decimal equivalent. Again, by adding by pi, you can also get 3pi/4. Right, and now we've got this typical show that something equals something kind of question. And again, the same logic applies to what I did before, which is we want to write this as a single fraction. The way that we do this is exactly like we did before. So I'm going to set this up as left-hand side to LHS. And what we want to do is write this as a single fraction where we multiply 1 minus sine theta by cos theta. So the way that we work out the numerator here is we multiply this by this. So cos theta times cos theta, that's cos squared theta. And then we multiply these two things together. So plus, and I might extend this slightly, 1 minus sine theta, 1 minus sine theta. Okay, so we've got something to work with here. What I'm going to do, just over on the right-hand side, I'm going to multiply this out separately. So I'm going to multiply out this double bracket. If I do this, 1 times 1 is 1, not 2, be careful. We have minus sine theta. Again, I'm just using our normal FOIL here, so first, outside, inside, last. Minus sine theta, and then plus sine squared theta. Signs are really important. Remember, minus times a minus is a plus. So if I pop this answer now over here, notice these two things together become minus 2 sine theta. I'm going to get then cos squared theta plus 1 minus 2 sine theta plus sine squared theta all over 1 minus sine theta cos theta. So it looks like we haven't made too much progress here at this particular point, but we can do, again, a little bit of jiggery-pokery here. First thing I'm going to do is put the cos squared and the sine squared together. So I'm going to do cos squared theta plus sine squared theta plus 1 minus 2 sine theta over 1 minus sine theta cos theta. Now the reason I've rearranged it here like this is that this particular part here, again, is another identity you need to know, and that is that cos squared theta plus sine squared theta is always equal to 1. The more practice you do on this kind of topic, the easier it certainly gets. That means I can replace this bracket then with just 1, and then we get 1 plus 1 is 2. So we are making progress. Doesn't feel like it, but we are making progress. Over 1 minus sine theta cos theta. And again, it looks like we've hit a roadblock, but you have to have faith in this, that it's going to work, and you just need to keep going. And next thing we're going to do here is that notice there's a factor of 2 common. So we can take a factor of 2 out. So we get 2. What do we multiply? What do we multiply something by to get 2? Well, we'll get 1. And what do we multiply to get minus 2 sine theta? Well, just sine theta. Again, you can check this by expanding the bracket. And notice we get a very convenient situation here, which is we get a shared bracket top and bottom. So we can just cancel these out. That then gives us then 2 over cos theta. And remember from what we did before here, 1 over cos theta is the same as sec theta. Therefore, we can just replace this then with 2 sec theta, which is equal to the right-hand side. And we've guaranteed those 4 marks, because if you get to the answer and you've done the correct logical mathematical working for it, you know you've got the 4 marks, and it's a very satisfying feeling in the exam. And now what's very, very typical on Add Maths, so be aware of this, is they'll use this word hence, and generally this means use what you just did to then solve this equation. Because you look at this and you think, what am I supposed to do with this? What am I supposed to do with this? Then you look at this a bit closely and then you compare this to this. And it's the same thing. But instead of having a theta, we just have a 3 phi instead. Notice exactly the same thing. So we can take the right-hand side of this, replace the theta with a 3 phi, and we can just replace the entire thing I've underlined. Therefore, this becomes 2 sec 3 phi is just equal to 4. Notice we're working in degrees for this, so that's something to be aware of as we go through. So that means then, if we divide by 2 on both sides, sec 3 phi is equal to 2. And now we want to work in cos and sine. It makes our life a bit easier. So what we can do here, remember, sec 3 phi is equal to 1 over cosine 3 phi. So we can rewrite this then. That's 1 over cosine 3 phi is equal to 2. And if you do a little bit of rearrangement here, again, we're going to go through all the details here. But I'm going to make this equal to a half. Again, you just flip both sides of the equation. Now, this is an exact value, and an Add Maths student, I'd expect you to know these exact values. They're very, very important as you go through. So what we're going to do, we're going to do inverse cos, very similar to how we did the previous question. This cancels, giving us 3 phi, which we're going to deal with a bit later on. And we're going to do the inverse cosine of a half. So it's very, very important at this point that you do know your exact values. If you do this on your calculator, you'll get 60 degrees. However, that is not the only answer. And the way that we can see this, again, I'm going to use normal trig graphs here just to give you an idea of what's going on. So we start at, for a cos graph, you start at 1, down we go, down, up, and around. This is working in degrees here, so 90 degrees. Again, this is 180, 270, and so on. And what we've done is worked out this answer here, so let me answer this in green. So 0.5. So we've worked out this answer here, which is equal to 60. But of course, there's this answer right over here that we need to be aware of. So we also need to work out this particular answer as well. So notice this length here and this length here are going to be the same. 90 minus 60 is 30, so 270 plus 30, that's going to give you 300. So we do have another answer. We do have 300 degrees. To add to this as well, we need to actually work out phi. So we need to write down some more answers so that we get within this domain. Again, we're going to do a bit of practice on this during this video. Remember, this graph repeats every 360 degrees. So I can add 360 to any of these answers and still get the answer of a half. So if I add 360 to 60, I get 420. If I add 360 to 300, I get an 660. I just want to go to the calculator and show that this 420 is an answer. So you need to go to degrees, so make sure you change it to the right setting. Notice if I do a cosine of 60, I get 1/2. If I do cosine of 300, I also get a half. If I do cosine of 420, I also get a half. So this is what I mean by there are more than one answer. Remember, your calculator is not that sophisticated. It can only give you one answer, whereas there are many different answers for this. Now, why have we worked out so many answers here when it's not within this domain? Well, we need to finish this off. We've worked out 3 phi, and we need to solve the equation. So we need to solve what phi is. So what's the opposite of timesing by 3? Well, we divide by 3 on both sides. So we're going to get just phi, which is what we're looking for. If we divide each of these by 3, we get 20 degrees, 100 degrees. Divide this by 3, we're going to get 140 degrees. And divide the last one by 3, get 220 degrees. However, look at our domain. We want the answers between 0 and 180. So we don't actually need to include this last answer. I did that on purpose just to show you that even though this is an answer, it's not an answer within the domain that we're given. So we don't need this one because it's more than 180. So these then are our three answers: 20, 100, and 140. My method is to write out quite a few answers here, and then when I do divide through by 3, I can then select the ones that I need for the specific domain, let me use that word, domain, in this particular question. Right, so you can check through the mark scheme here. So this was A that I showed you before. This is part B. Again, there's a couple of alternatives in terms of methods. I've taken the top method here in order to work it through, but you can see the alternatives down below. And another alternative as well, and then the last part of the question where we work out 20, 100, and 140. Right, on to our next question. Again, this is quite a tricky topic, so it's worth really paying attention and going through these carefully. And we need to show that this expression here is the same as cos theta. So again, we're going to use all those different identities that we've seen before. Sec theta, that's equal to 1 over cos theta. So I'm just going to put all these in. Remember, tan is equal to sine theta over cos theta. That's what we've seen before. And then finally, cosec of theta, well, that's equal to 1 over sine theta. So the general strategy here is when you're working with secs and cosecs and tans and things like this, let's get everything in terms of sine and cos, and then we can deal with it as we go through. So the first thing to do here is a nice little trick. When you're dividing by another fraction, what you can do is take the very bottom of the fraction and bring it to the top. Now, if you don't like that, let me just show you this in a slightly different format. Sine over cos. Essentially, we're dividing by 1 over sine theta. If I use that divide symbol we tend to use in year 8 and year 9. Now remember, keep it, switch it, flip it. So we keep the first fraction, we change this to a times, and we flip this fraction. And once you see this, that makes more sense of the trick that I've done over here. So we get sine squared theta over cos theta. So nice little trick to remember, very good for algebra. Whether you're doing IB or A level later on, it is a useful trick to know. So we get sine squared theta over cos theta. Okay, well, we've got the same denominator here, so that's kind of handy. So we can just put the two fractions together directly. So we get 1 minus sine squared theta all over cos theta. Again, just have to have faith that it is going to simplify down. You're going to get cos theta at the end. Now I look at the top here and go, well, it's linked to this in some way. So sine squared theta plus cos squared theta is always equal to 1. And I think, well, I could rearrange this to make cos squared theta the subject. So if I take away sine squared theta from both sides, I will get, this will cancel. Let me just write this out in full. So sine squared theta minus on both sides. This cancels, so we're just left then with cos squared theta. And that's always going to be equal to 1 minus sine squared theta. So knowing rearrangements of these trig identities is really, really important too. And then I go, well, I've got 1 minus sine squared theta. It's the same as cos squared theta. I can just replace it on the top. So this then becomes cos squared theta over cos theta. Then I can cancel top and bottom of cos theta, and I'm left with just cos theta, which is conveniently the right-hand side that we saw right at the start. So just work it through. My general strategy here, just change everything to sine and coses, and then you're going to get a lot of simplification using these identities on the right-hand side. Okay, and now, again, very typical. They want you to solve an equation that looks, on the surface, absolutely horrendous, because, I don't have to deal with this at all. But then we look at this, and we look at what we just did, and they're identical apart from we've got, instead of theta, we have 2 theta. That's the only difference. So we can take the right-hand side, cos theta, we just pop that down here, and that will be equal to the right-hand side of this equation, which is root 3 over 2. So you can simplify it down, and then you get an answer you can work with. At this point, again, we're going to approach it very similarly to the previous questions. What's the opposite of cosine? Well, inverse cosine on both sides. This cancels, so we're left with 2 theta equals the inverse cosine of root 3 over 2. Again, this is another exact value you should know. So it's important you know these exact values and you get used to just knowing it without using the calculator. Again, you can check this on the calculator. Obviously, we get 30 degrees here as our first answer from the calculator. Now, if we do this very similarly to how we did before, think of your cosine graph. Starts at 1, comes downwards, round, working in degrees here. So, minus 1 down here. This is going to be 90. This is going to be 180, 270. And we've worked out this answer, so the 30 answer here. So let's pop that in. So right up here somewhere. So there's your 30, where this is root 3 over 2. But then don't forget, we've also got an answer right over here as well. So it's important to remember that very, very clearly. This length here is the same as this length here. If this is 60, then this needs to be 60. Therefore, we get our second answer of 330. Excuse me. And you can write out every other answer as well. So you're adding on 360 each time. So you could write down 390, for example. 360 plus 30 is 390. This time we're dividing by 2 on both sides. Again, I don't need to write down any more answers, but you could just by adding 360 to these answers from before. Cancel this. We're left with then theta is equal to, well, 15 degrees. Divide that by 2. It's 165 degrees. And if we divide that by 2, that's 195 degrees. But we don't want this one. Again, our range here is 0 to 180, so we don't need this. So these are our two answers for this particular equation, 15 degrees and 165 degrees. Okay, and now on to a slightly trickier question here. So notice we've got something slightly strange in the bracket here, and that's going to change how we work with it. Notice our domain is also a bit different. So we're going between 0 and 2 pi radians. That's the same as 360 degrees. So keep that in mind as we go through. Now, first of all, we want to make essentially phi the subject, but it's going to take a little bit of time. The first thing we're going to do is divide by 2 on both sides. That cancels, leaving us with sine squared phi plus pi over 3 is equal to a half. Now we do, what's the opposite of squaring something? We're going to square root both sides. So we have to be very, very careful. This cancels, leaving us with sine phi plus pi over 3. Now, when we do the square root of this, this is going to give us plus minus. Remember, you get two answers when you square root of the square root of a half. Now, this will be equal to, the square root of 1 is 1, so 1 will stay on the top, but we get the root 2 down below. Again, this leads into another exact value that you should be aware of. So we'll talk about that in a moment. Notice we've got plus and minus. So that's going to make things a bit tricky as we go through, but if we draw a good sign graph, we can read off all the answers that we need. First thing I'm going to do here, I'm going to take the positive version. So I'm going to take 1 over root 2. We'll come back to minus 1 over root 2 later. And what's the opposite of signing something? Well, we want to inverse sine both sides. This cancels, giving us phi plus pi over 3 is equal to the inverse sine of 1 over root 2. Again, this is what I expect an Add Maths student to know this off by heart. Again, you can check this on your calculator as well. Well, this is equal to 45 degrees, but remember, we are working in radians. So 45 degrees, again, this is something you also need to know off by heart, is equal to pi over 4 radians. So this is going to equal then pi over 4 as one of the answers. But now we're going to draw a sine graph just to read off all the answers we need in order to answer the question. So here's my sine graph. Remember, sine graph is different to cosine. So we're going to go up and then down and then down and then back to here, where this is going to be pi over 2. This is going to be pi, and this is going to be 3 pi over 2, and this is going to be 2 pi. As you've seen in this kind of question and some questions before, you really have to be good with your transferring between degrees and radians. It needs to be very natural. If we mark in the 1 over root 2 answer, so the positive one, let's start with that first. Well, that's going to be roughly around here. So this is pi over 4, the answer that we've worked out. And this is 1 over root 2. So we've also got another answer to consider over here, which is this answer here. This length will be the same as this length. So in order to work out this particular answer, we're going to do pi minus pi over 4. Well, that gives us then 3 pi over 4 radians. So let's write in that answer. And then we also need to consider this plus pi over 3 later on. So what I would do, remember this repeats every 2 pi radians, I would also add in that. Now 2 pi is equal to 8 pi over 4. So I'm going to add 8 pi over 4 to each of these answers to generate 2 more answers. So pi over 4 plus 8 pi over 4 is 9 pi over 4. And I'm also going to put in 8 pi over 4 plus 3 pi over 4 is 11 pi over 4. I might not need all these answers, but I always want to make sure I've got lots of answers so I can cross out any at the end I don't need. Now, the same process would also apply for the negative. So let's come back to the negative here. So we'd also need to work out sine inverse of negative 1 over root 2. And this is where we're going to use the symmetry of the graph. So if we look at the graph that we've got here, and I'm just going to generate this in black this time. So this would be my minus 1 over root 2, the same distance away. So we've got this symmetry going on. And notice we get 2 answers here. We get this answer here and this answer here. And if I go upwards, we're going to read off these 2 in a moment, where these 2 lengths are the same. So if this is pi here, we're going to add on pi over 4 to actually get this answer. Well, pi plus pi over 4, that's going to equal 5 pi over 4. Again, your calculator will probably give you a negative answer, but this is a very quick way to get to the positive answers. Likewise, this is also pi over 4. So what's 2 pi, 8 pi over 4, minus pi over 4? Well, this is 7 pi over 4. So we then generate two more answers, 5 pi over 4, 7 pi over 4. And again, we can work out extra answers by adding on 8 pi over 4. I'll do one of these. So 8 pi over 4 plus 5 pi over 4 is 13 pi over 4. We may not need this, but we've got it there. Notice there's a pattern here. So we've got 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, 9. So let's keep going up in twos. So we can use that to help us when we work out the final answer. Now we want to work out phi itself. So what's the opposite of adding pi over 3? Well, we're going to minus pi over 3 on both sides. This cancels, leaving us with phi, which is what we're looking for. And now we have the fun job of minusing pi over 3 from each of these answers. But once we've done the first couple, you can probably see the pattern. First of all, we're going to do pi over 4 minus pi over 3. So let me do that over here. So pi over 4 minus pi over 3. Well, common denominator is 12. So what we can do here is get then 3 pi over 12 minus 4 pi over 12, which is minus pi over 12. But that's not in my domain because we're starting from 0. So that is an answer I don't need to worry about. Let's then go on to 3 pi over 4. So if I do 3 pi over 4 minus pi over 3, do it in the same way, I get out of 12, 9 pi over 12 minus 4 pi over 12. That's equal to 5 pi over 12, which is in my domain, so I can include that. So I get 5 pi over 12. Now if I do the same procedure, let's rub this out. So I'm going to cross them off as I go along so I don't make any mistakes. There we are. Let's now do 5 pi over 4. So if I do the same process, I'm going to get then 15 pi over 12 minus 4 pi over 12. That gives me 11 pi over 12. So that's also within the domain. It's just less than a single pi. And let's just do one more just for clarity so you can see what's happening here. So I'll rub this out. If you find this very useful, we're getting some of the hard questions here, then do like and subscribe. What are we doing next? So we've done 5 pi over 4. Let's do 7 pi over 4. So it's going to do 7 pi over 4 minus pi over 3 times to get the common denominator. So that gives us 21 pi over 12 minus 4 pi over 12. That gives us 17 pi over 12. So let's pop that in. And now you can probably see the pattern with these answers. It's going up by 6 pi over 12 each time. So we can just add on 6 pi over 12 for the next one, which is 23 pi over 12. Notice that just fits into our domain. You can write 2 pi here as 24 pi over 12. So it's just fitting in. And if I was to do the next one, you notice that wouldn't quite fit in. So if I tried 11 pi over 12 and did the working there, that's not going to fit into the domain. So finally, we have our answers here. 5 pi over 12, 11 pi over 12, 17 pi over 12, and finally 23 pi over 12. So you can check the answers here for all of the parts of the question. That's the end of the trig equations section. Again, if you want more practice on this, I know this is a hard topic on the Add Maths course, then please do let me know in the comments and maybe I can make an all of Add Maths trig equations section. And number 5, I'm sure you are expecting, is the binomial expansion. So we're going to look at two questions, one really big question that we're going to go through, and then a shorter question to really give you all the skills you need for this course. Okay, and on to the binomial expansion part of this video. Very important if you're going to IB, analysis and approaches, or any of the A-level courses. So the first three terms in the expansion of a plus x to the power of 3, 1 minus x over 3 to the power of 5, the ascending powers of x can be written in this particular form. So up to x squared, which is going to be important later on, where a, b, and c are integers. So if we don't get integers, bad things are happening. And we somehow need to find what a, b, and c are. Now, the first thing I notice is this up to x squared. So I've got these expressions here. All I need to do is write each of these brackets out as far as x squared. So that's going to save me a bit of time when I do these expansions. So a plus x to the power of 3. Right, let's work through our binomial expansion. So the first part is nice and straightforward. So we're just going to take a cubed. At this point now, we're going to then start using these permutations and combinations kind of notations. So I'm going to do 3c1, and we want to reduce the power by 1 here, so we're going to have a squared, and now we introduce the x, so times by x. Then we're going to do 3 choose 2. Again, we can use our calculator to work this out, or Pascal's triangle. We're going to reduce that index by 1, so that's going to be a. I'm going to increase the index here by 1, so that's going to give us x squared. And then finally, we have 3 choose 3, and we're going to be left with just the last term, so we're going to have x cubed. If I simplify this down, well, I get a cubed, and if you're not sure of what 3c1 or 3c2 is, let me go and show you just now. If you ever want to work this out, on my calculator it's a bit more complicated, but you'll see a button on your calculator called combinations with a C or an NCR. All you have to do is type in 3,1. That then gives you 3, for example. If I wanted to work out 3 choose 2, for example, then my calculator 3 choose 2, that also gives me 3 as well. So I'm generally going to do this from memory of Pascal's triangle, but you can do this using the calculator. So we get 3c1, well, that's equal to 3, so we get 3a squared x. Here 3c2 was also 3, so we get 3ax squared. And I could work this out, so 3c3 is just 1, get x cubed. But remember, we don't really need this term because we only want to go as far as x squared. This is going to help us even more in the next question, so 1 minus x over 3 to the power of 5. The first thing is a nice easy one, so it's 1 to the power of 5, that's just 1. Then we're going to start using this notation here, so 5, that also comes from the index here, choose 1. We're going to reduce this by 1, that doesn't really matter here because 1 to the power of 4 is still 1, but we're going to introduce this minus x over 3 at this point. Then we're going to do the next term, so we get 5 choose 2, and we get minus x over 3 all squared. Notice I don't need to go any further because next term will be something to do with cubed, which I don't need. So all I need to do is work this part out, so 1. Now 5 choose 1 is just equal to 5, so we get 5 times minus x over 3. So let's change the symbol here to a minus. So we get minus 5x over 3. Now 5 choose 2, that's going to be equal to 10. So we're going to have 10. Now if we square this bracket, remember it becomes positive, so that's really important. So we're going to get x squared over 9. X over 3 times x over 3 is x squared over 9. Again, the rest of the terms don't matter. And let's simplify this down. So 1 minus 5x over 3 plus 10x squared over 9. So that's the approximations I need for both of these terms expanded. I just go as far as x squared. That's all I care about for this because I'm working out b and c. There is no x cubed term. So what we're going to do now, and it's going to look quite intimidating at first, is I'm going to write these two things together. Plus 3ax squared times then by 1 minus 5x over 3 plus 10x squared over 9. And we want this to be equal to 27 plus bx plus cx squared. Right, so the first thing we're going to consider is how do we get a constant term, i.e. something without x? And the only way we can generate that is when this times by this. Okay, anything else is going to involve an x in some way. So 1 times a cubed is just a cubed, and that, so this answer here, let's highlight it, has to be equal to the constant term here. So a cubed must simply just be equal to 27. And so to get a on its own, what's the opposite of cubing? Well, we want to cube root both sides, like so. This cancels, giving us a, and then the cube root of 27, well, that's just equal to 3. So first of all, we've worked out a is equal to 3. It's going to be really important for the next part. Now what gets a bit more tricky here is working out how we generate the x term. Now there's a couple of ways we do this. First of all, this times this gives us an x term, and this one times this one also gives us an x term. Anything else is going to give us either an x squared term or something even higher. So the only way we can generate an x term is this times this and this times this. Right, so let's actually work this out. So a cubed times minus 5 over 3x, that's going to give us minus 5 over 3 a cubed x. This term here, well, 1 times 3a squared x is just going to give us plus 3a squared x. And this is going to be equal to bx. So we've written down our equation nice and carefully here. That means then that if I get the highlighter out again, the coefficient, so this adds this, must be equal to b. So we can then go b is equal to, and we can reverse this around if we so wish, so 3a squared minus 5 over 3a cubed. And remember, we already worked out a from the previous question. A is 3, so we get 3 lots of 3 squared minus 5 over 3. We know a cubed is 27, so we can pop that in. Again, you can use your calculator at this point. I don't like calculators, so it's fine. I'm just going to work this out. So get 27. Here we're going to get minus 45. 27 divided by 3 is 9. 9 times 5 is 45. And if we do 27 minus 45, we'll then get the answer of minus 18. So we've got our value for B. Now C gets a bit more complicated because there's many different ways of generating our x squared term. So we have to be very, very careful how we do this. First of all, this one here, I think that's quite straightforward. So this times this gives us an x squared term. This one times this one also gives us an x squared term. And don't forget in the middle as well, because you've got x times x, that also gives us x squared too. So we've got 3 different ways of working out an x squared term. Let's go through these. So we'll do the outside one first. So this times this, that's going to give us 10 over 9x, a cubed, sorry, 10 over 9 a cubed x squared. So that's that one done. We've got the one in the middle, which is quite easy. So we've got plus 3ax squared. And then this one's a bit more complicated here. So we've got 3a squared times minus 5 over 3. 3's cancel, so we're left with just minus 5a squared. And that has to be equal to cx squared. And then we use the same idea that we did before. So this part here, plus this part, plus this part. Sorry, we should have an x squared there as well. Being consistent, there we are, has to equal this c here. So let's just highlight that. So those things have to be equal. If we have that, so therefore c is equal to 10 over 9 a cubed plus 3a minus 5a squared. And again, we know what a is, so we can just substitute it in. So we get 10 over 9 times 27. 3 times 3 is just 9. 3 squared, 9 minus 45. Simplify this down. 27 divided by 9 is 3. 10 times 3 is 30. 30 plus 9 minus 45. and that's equal to minus 6. So just for the clear for the examiner, I'm just going to write here A is 3, B is minus 18, C is minus 6, and I have the 3 answers I'm looking for those 8 marks. And what's even better, if I'm in the exam here, I know they're integers, which is a good sign because it did say these are integers in the question. Right, so you can see the answers there for question 4. That's quite not a very nice question 4 because there's not much guidance as you go through that particular question. So hopefully this video is helping you so far. Right, on to this question, which is a bit more straightforward, a bit more typical. So first of all, they want us to expand this out, so in full. So the way that we're going to do that, first of all, the first term is always easy. The first and last terms are easy. So we just do 2 to the power of 4. Now we start bringing in this C notation. So we get 4C1. They reduce the power by 1, so we get 2 cubed. Now we introduce the minus 3x in. Then we're going to have 4C2. We reduce the index by 1, so that gives us 2 squared. And now we're going to increase this by 1, so that gives us minus 3x all squared. Then we've got 4C3. We're going to reduce this by 1, so we just get 2, or 2 to the power of 1. And then we increase this by 1 to give us to the power of 3. And then lastly, 4C4. That's just going to be the last term to the power of 4. Now this kind of question, it is worth just writing out the steps and not rushing through this kind of question. So 2 to the power of 4, that's just equal to 16. Now let's go through this. Now 4C1, you can check on your calculator, that's going to be equal to 4. So we're going to do 4 times 2 cubed is 8 times minus 3. So I'm just going to write that out in full and come back to it. And next one here, well, that's going to be 6. I mean, we can check this on the calculator. So just in case you're wondering, where are these things coming from? Let me just put it on the calculator. So combinations, you just go 4, 2, gives you 6. So these numbers are not random. They do just come from your calculator. So we have 6 times, or 2 squared is 4. Now this is where to be careful. Minus 3x all squared is equal to 9x squared. So we're going to have a 9 there. And then don't forget the x squared. 4 choose 3, that's equal to 4. We've got the sort of mirroring idea here. So we've got 4 times 2 minus 3x all cubed. That's minus 27x cubed. So times minus 27x cubed. And then the last term, well, 4 choose 4 is just 1, so that's helpful. This to the power of 4 minus 3 to the power of 4 is 81. So we're going to get 81x to the power of 4. Now we're just going to simplify this down. So we've got 16 here. Again, you can use your calculator to help you here. Again, the first thing to realize is going to be negative, of course. We're going to have this sort of negative, positive idea. 8 times 4 is 32. 32 times minus 3 is minus 96. This one here, so we've got 6 times 4 is 24. 24 times 9, that is equal to 216. So we get 216x squared. This one here, 4 times 2 is 8. 8 times minus 27. 216 as well, but we've got a minus here. And make sure you've got x cubed. Don't just copy it from here. And then we've got our last term there. 81x to the power of 4. Now, very typical in these Add Maths questions, you're going to be using what you've just done here and applying it in the next part of the question. So, the sum of the first 3 terms in ascending powers of x in the expansion of this, notice this is just what we've just been doing, times 1 plus a over x is this here. So notice we only need to go as far as the x term. It's very similar in format, but a little bit different in terms of calculation. And we need to work out a, b, and c where they're integers yet again. So before I do anything, I'm just going to copy out what I did before. I probably don't need it all, but I'm just going to copy it out in full, just so I've got it here to work with. Minus 216x cubed plus 81x to the power of 4 times 1 plus a over x. So essentially that's what I'm considering here. We only need to go as far as the x term. We have to be a little bit careful on that because notice this one here times this one will give me an x term. So I can ignore anything here. So I'm not going to deal with these two terms here, but I am going to focus on these. Right, the first part is fairly straightforward here. So I want to work out the divided by x term. The only way I generate that is by timesing this by this. Anything else is not going to give me an over x term here. So if I work this out, so we're going to get 16 times a over x, that gives me 16a over x, or I can separate this out and make this look like 16a 1 over x, and this needs to be equal to the first term, which is 32 times 1 over x. So that leads me to this part here must equal this part here. So 16a is equal to 32. And if I work this out, then a is equal to 2. So usually the first one is quite easy to work out. Now we need to consider the, let's get a different color pen here, the b term, so just the number term. How do I create a number from this? Well, there's a couple of ways of doing this. First one is timesing this by this. This gives me a number term. This times this also gives me a number term as well. So there's only two things to consider here. So first of all, we've got 1 times 16, that's just equal to 16. And then we've got minus 96x times plus a over x, x's cancel. We get then minus 96a. And then this just needs to be equal to b. So therefore, b will be equal to, you know what a is already, minus 96 times 2. And you know what, I'm going to use the calculator for this one. So we're going to get 16 minus 96 times 2, and that gives us minus 176. Okie doke, and now we're going to work out the last one. Let's do this in blue. How do we get the just x term here? Right, so we've got a couple of choices. We've got this one here, so this times this gives us that, and we've got this one here. Got to be careful. So this one here times this one here also gives us just an x term because x's cancel. So if we work this out, then 1 times minus 96x is just minus 96x. This one times this one, x and x cancels, so we get plus 216x, and that needs to be equal to cx. And like we did in the previous question here, that means then this part and this part need to be equal to, we've got an a as well. I knew there was something I forgot there, so we've also got an a as well, minus 216a, and that has to equal that. Therefore, c is equal to minus 96 plus 216a. We know what a is from the previous question, so minus 96 plus 216 lots of 2. Pop this into our calculator, minus 96 plus 216 times 2. I'm getting the answer of 336. So our final answers again, I'm going to write it nice and clearly for the examiner. So we get a is 2, b is minus 176, and c is equal to 336. Again, very likely these are the correct answers because all the numbers here are integers. If something went wrong, you're probably going to get a fraction, and you'll know that's not the right answer. You can check your working, so that's question 2a that we did before, and then on to question b here, going through that particular part as well. So this is the binomial expansion part of the video, so I hope you found that useful, and we'll move on to the next part. And if you're finding this video useful to you so far, then please do like the video, the most important thing to do, and subscribe to the channel as there'll be more IGCSE Add Maths content coming out. Number 6 here is differentiation, so the first of the two parts of the calculus. I'm going to go through many different questions here using the quotient rule, product rule, chain rule, and really get you up to speed on what you need to know. Okay, and on to the calculus part of the video. I'm sure you've been waiting for this, and we're going to start with differentiation first, and then the next section, integration, afterwards. So we have a curve with this equation here, x squared minus 5 to the power of a third over x plus 1, where x is greater than minus 1. That becomes important. And we need to show that the derivative of this is this horrible expression here. Now, the first thing I notice here is I've got a fraction. Now, as soon as you get a fraction, you're differentiating, you're going to be needing what's called the quotient rule. And as part of the course, you need to be able to use the chain rule, the product rule, and the quotient rule effectively. In this particular short section of the video, I'll be going through chain rule and quotient rule quite a lot. Now, the quotient rule, I tend to remember this as VU dash minus UV dash over V squared. I use this kind of short notation here when dash indicates the derivative. So the first thing I'm going to do here is identify my U and V. So this top part is going to be U and the bottom part is going to be V. So I'm going to then write down U equals x squared minus 5 to the power of a third. And the first thing I want to do is derive this. Now, with the bracket here, we're going to need the chain rule. So I'm going to bring the third to the front. I'm going to differentiate the bracket, which is going to be 2x. And then I'm going to leave the bracket alone. Don't touch it. But I am going to reduce the index by 1. This has to be really careful. So you're doing 1/3 minus 1. So this is the calculation I'm doing. And remember, that's the same as 1/3 minus 3 over 3. And that's equal to minus 2/3. So we get to the power of minus 2/3. Now we're going to take the v part. So v is equal to the bottom part, which is x plus 1. And that's a nice derivative because v dash, if we differentiate just x, a linear part, of course, it's got a gradient of 1. So therefore, that's going to be 1, making our formula a bit easier. Therefore, now we're going to get into the fun part, which is substituting it in. So vu dash, first of all. So we've got an x plus 1. U dash is this horrible expression here. So we get 2/3 x brackets x squared minus 5 to the power of minus 2/3. That's all one expression. Yes, just that part there. Minus uv dash. Now, luckily, v dash is just 1, so we get minus x squared minus 5 to the power of a third. And then all divided by v squared. So this part here, we're going to get then v squared. Okay, so this is what we've got to work with so far. Let's have a think how we want to go from here. I'm going to tidy it up first of all. So that's going to be my first instinct here. So let's bring the 2/3 x to the front. We've got x plus 1. We've got an x squared minus 5 to the power of minus 2/3 minus x squared minus 5 to the power of a third all over x plus 1 squared. Right, so having a look here, my first instinct is I'm trying to make the bottom look like this. This is my first instinct to do here. So what I can do is times top and bottom by 3. That's the first thing I can do. So if I do that, I get a 3 here, which is what I want. This is then going to cancel down to 2x, like so. And we're going to get a 3 here as well. Okie doke. Right, at this point, I think, well, I want this down below. So I'm going to times top and bottom by x squared minus 5. So I'm going to times the bottom here by x squared minus 5 to the power of 2/3. And then I'm going to multiply each of these terms here by x squared minus 5 to the power of 2/3. Well, that's kind of useful for here because this is going to just cancel, which is really handy. So that's going to cancel and that's going to cancel with there. But don't forget, I'm also timesing this by x squared minus 5 to the power of 2/3. Well, if I do that, this times this is very useful, because notice I can just add the indices, so that just gives me x squared minus 5. So let me generate a quick page. To write out what we've got here. So let's just copy this down correctly. So dy by dx is equal to 2x brackets x plus 1. That stays where it is. We've times this by x squared minus 5 to the power of 2/3. That just becomes x squared minus 5. So we get minus 3 x squared minus 5. And then the bottom is exactly what we want. So 3 is fine. X plus 1 all squared is fine. X squared minus 5 to the power of 2/3. So now it's a case of just taking the numerator, expanding and simplifying. So if we do this, I'm going to put dot 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 at the bottom for the moment. If we expand this out, we get 2x squared plus 2x minus 3x squared plus 15, so be careful there. And then if we simplify this down, we get minus x squared at the top plus 2x plus 15 over 3 brackets x plus 1 squared x squared minus 5 to the power of 2/3. And let's check if that's what they wanted. Well, they want it as a quadratic, so a, b, and c, so minus 1 plus 2 and minus 15. Perfect, we've got to the correct answer. Quick tip about doing this kind of question. Notice when I got to this point here, I've got part of the denominator that I want. So in order to generate that bottom part, I just times top and bottom by these things, and you kind of hope at this point then the top will simplify to something nice, but that's quite a nice method. I know what I want, I know what I have so far. It's times top and bottom by 3, and times top and bottom by this second bracket, and then I'll generate what I want at the end. Now we need to find the x-coordinate of the stationary point on the curve. Whenever you see stationary points, you need to be thinking dy by dx is equal to 0. First thing that must come into your mind. So we want to take this result that we've just generated here, minus x squared plus 2x plus 15 over the denominator plus 1 all squared x squared minus 5 to the power of 2/3 is equal to 0. Now this actually isn't as bad as it looks, because if a fraction is equal to 0, then we know the numerator must be equal to 0. Therefore, we know minus x squared plus 2x plus 15 must equal 0, which is just a quadratic to solve, and we've seen quadratics in earlier parts of this big video. So the way I tend to do this, kind of lazy way, I multiply both sides by minus 1, so I switch the signs essentially, because I like factorizing into this form instead. If I put this then into 2 brackets, so 2 numbers that multiply to give me minus 15, add to give me minus 2, that's going to be minus 5 and plus 3. Therefore, x must equal 5 or minus 3. However, if you go back, notice that x must be greater than minus 1. Notice this is not greater than minus 1, so we cross that out, and this is our only answer here. X equals 5. Now, if I wanted to work out whether that point was a maximum or a minimum, the first thing that I would do here, I don't actually have to work this out, but I'm going to work it out in this question anyway. I would differentiate this again, essentially, so you do d2y over dx squared. Again, that's quite complicated to do, but that's what you aim to do. So you work out d2y over dx squared, so the second derivative. So that's the first thing that we need to do. Then we substitute in x is equal to 5 into second derivative, so into d2y over dx squared. If negative, then it's a maximum, and actually I think this probably is a maximum. If positive, then it's a minimum. So interesting question. They don't usually have these sort of description style questions, but if you're trying to work out a stationary point, the standard method is to find the second derivative, then substitute that 5 into the second derivative. If it's negative, it's a maximum. If it's positive, then it's a minimum. Right, so you can check through the working there. Again, that's why I do these kind of videos, because you see the mark scheme and you go, what do I even do with this? Hopefully this video has made it a little bit more clear. And then of course you've got parts B and C. There are many alternatives for doing part C, but second derivative, work out if it's positive or negative when it's substituted in, is the standard approach and the easiest approach to do. Right, on to the next question, which is quite different in style. So we've got natural log of sine x plus 3 cos x, and notice our domain is in radians. Keep that in mind a bit later on, between 0 and 90 degrees. And we need to find dy by dx. Now, if we take the natural log function, so this is essentially a chain rule question. If you have a function within a natural log, then if you want to derive it, the formula for this is you take the derivative of the function inside and put in the numerator, and you put the original function down below. So if we apply that to this particular question, the derivative of this function, well, if you derive sine, you get just positive cos. If you derive cos, you get minus sine, so you get minus 3 sine x. And then you just copy down the function down below. So you get sine x plus 3 cos x. You do need to remember these important facts. So if y equals sine x, then y dash or dy by dx is cos x. And if you have y equals cos x, then you need to remember the derivative of that. You can see it's important in other questions you've seen already, is negative sine x. And what they want us to do with this question is take that answer and find the value of x. Notice value only, so keep that in mind, for dy by dx is equal to minus a half. So we take our previous answer, so we take cos x minus 3 sine x over sine x plus 3 cos x, and make that equal to minus a half. Excuse me. And probably the easiest way of solving this equation with this particular one, fraction equals fraction, is just do some cross multiplying here. So multiply this by this and this by this. It doesn't matter where the negative is. So if we times it by 2, then we get 2 cos x minus 6 sine x is equal to negative sine x plus 3 minus, be careful, lose concentration for a second, and this is what can happen. So minus 3 cos x, so it's really important we get that correct. We're going to collect up the like terms here, so I'm going to bring everything to one side. So we're going to add 3 cos on, that's going to be 5 cos x. Oh, okay, this is going to be quite nice. So we've got plus sine x on both sides, minus 5 sine x equals 0. I'm going to bring, which way around do I want to do this? Bring the cos to the other side, so we get minus 5 sine x is equal to minus 5 cos x. At this point, we can then divide through by cos, so we get minus 5 sine x over cos x is equal to minus 5. Remember, sine over cos, you remember this from previous part of the video, is equal to tan, so we get minus 5 tan x is equal to minus 5. Divide both sides by minus 5, we get tan x is equal to 1. In fact, relief at that point, you get something quite nice. And of course, what's the opposite of tanning? Well, we're going to do inverse tan on both sides. That cancels, so we get x equals the tan inverse of 1. Now that is an exact value you should know. You should know that's 45 degrees. Remember, 45 degrees is equal to pi over 4 radians. I did say watch out for the radians. It is there. So our answer is pi over 4. Notice that's our only answer for 2 reasons. So this is the correct answer. 1, find the value of x. So there can only be one answer. And 2, if you go back to the domain, is between 0 and pi over 2, 0 and 90 degrees. So if we were to generate another answer by adding on pi radians, that would be outside the domain which we need. Okay, so have a look through the answers here so you can check through and look at everything I've done in this section. So that's the first part of our calculus done. And number 7 here is integration. So we're going to go through a really big 9-marker question, which is really going to test your knowledge of logs as well as applying integration in a more real-life context. Okay, and on to the second half of the calculus part of Add Maths, and this is where we're going to look at some integration. So here we want to find the exact value. Now that's important. So as soon as they start saying exact value, you need to write this in terms of natural log or roots or something like that. So do keep that in mind. Now, notice we've got x plus 1 all squared over x squared. Now, lots of people try and rush to doing integration by parts, by substitution, but your standard approach here should be to just expand things out and then get things in forms where you can work out each part of it separately. So, what do I mean by this? Well, let's get started on this. So, we're going to work between the definite integral here of 4 and 2, the limits of 4 and 2, and what we're going to do is expand at the top of this. Remember, this is the same as x plus 1 times x plus 1 on the top. So if we expand that out, we get x squared plus 2x plus 1 over x squared dx. And notice here we can actually separate out each part of this. So what do I mean by that? Well, we can take x squared, the first part, divided by x squared. Then we can do 2x, the second part, divided by x squared. And then for lastly, 1 over x squared dx. And what we're doing is just massaging here the integration, so we've got something that we can integrate. Now let's just work this out. So between 4 and 2 here, x squared over x squared is just 1. 2x divided by x squared, notice we have an x cancelling, so we get plus 2 over x. And then finally, this here, 1 over x squared can be written as x to the power of minus 2 dx. Now we've simplified it down into something that can be integrated quite easily. Now remember the rules of integration. So if we want to integrate 1 over x, this is a special case, then that's going to give us the natural log of x plus c, not forgetting the constant of integration without limits. Now we do have limits here, so it's going to be a little bit different. We're going to integrate each part here separately. So if we integrate 1, we just get x. Remember, you can always check this by differentiating and working backwards. 2 over x, that integrates to 2 ln x. And now we use our standard integration rules for this. So the way that we integrate this is we add 1 to the index, so we get x to the power of minus 1, and then divide by the new index, which is minus 1. Now remember, there's no plus c here because this is a definite integral, because we're going to be working between 4 and 2. I'm just going to tidy this up very quickly. So what I'm going to do here is just write down x plus 2 natural log of x. And here we can just write this as minus x to the power of minus 1. Like so, between 4 and 2. Now to integrate a definite integral here, we're going to substitute in 4 first of all. So I'm going to get 4 plus 2 ln 4 minus 4 to the power of minus 1. And now I'm going to minus the 2 parts. So I'm going to substitute 2 into here and then minus that from what I did before. So I get 2 plus 2 ln 2 minus 2 to the power of minus 1. Remember, 2 to the power of minus 1 and 4 to the power of minus 1, well, these are just equal to 1 over 2 and 1 over 4. So let's finish this off up here. So if we simplify this down, well, we have 4 minus a quarter, so we're going to get ourselves 15 over 4. Now this here, natural log of 4, I can rewrite this as 2, the natural log of 2 squared. You're going to see why that's useful in a moment. And then we're going to minus, well, 2 minus a half, that's over 3 over 2. Now 3 over 2 is the same as 6 over 4. And we'll leave the 2 ln 2 as is for the time being. And if I continue the answer here, well, 15 over 4 minus 6 over 4 is 9 over 4. And remember that I can bring this 2 with logs and bring it to the front. So I get plus 4 ln 2 minus 2 ln 2. And we can simplify this now quite easily. So we get 9 over 4. Well, 4 ln 2 minus 2 ln 2. Imagine this is 4a minus 2a, where you just get 2a. So we get 2 ln 2. Now this is an exact value, remember, because I've written this in terms of a log. I haven't rushed to my calculator in this particular question. So you can check the answers here. One thing to notice about the working here, there is a mistake in the mark scheme here. So they should have written in a plus 2 ln4 instead. You get to the answer here, but they've just put a mistake in the working as we go along. Right, on to a more difficult question. Starts off nice, but it gets difficult as we go along. And first of all, we need to show this here is equal to this here. Now this is reasonably easy to do here by creating a common denominator, a common topic, generally on the Add Maths course. So what I'm going to do here, I'm just going to multiply the two denominators together. So x plus 1, 3x plus 10. And now we use the cross-multiplying idea, not cross-multiplying, but we're using that same idea of this times this and this times this. Well, 1 times 3x plus 10 is just 3x plus 10. And then we do two lots of x plus 1, so that's 2x plus 1. And notice for this question, they do want us to expand at the bottom here. To expand the bottom part of this fraction, we get 3x squared. And that's the first term. Then we've got the outside term, so that's plus 10x. Inside term, 1 times 3x is 3x. And then 10 times 1 is 10. And then at the top here, we're just going to collect like terms. So 3x plus 2x is 5x. And we see, this is where we always check here. So notice this should be a 12. If we did this, we get 11. And when we multiply this, we forgot that 1 times 2 is 2, which is a good thing to do. So again, use the answer to help you as you go through your working. And then 10 plus 2 is just 12. And if we tidy this up slightly, we get 5x plus 12, which is what we wanted. And then 3x squared plus 13x plus 10. And that's what we want in the denominator. So when you ever get these show that questions, we saw this in the trig equation section in section 4. Use the show that to guide you through to the correct answer. Right, we've got a massive 9-mark question here. So it's going to take a little bit of work to go through. So the diagram shows part of the curve y equals 5x plus 12 over 3x squared plus 13x plus 10. Now as soon as I see this, I go, we just had this in the previous part of the question. Notice we wanted to write that in terms of two fractions. That's interesting, keep it in mind. So the line x equals 2, which is here, and a straight line of gradient 1. So this is this PQ line over here. The curve intersects the y-axis at the point P. Yep, got that here. Line of gradient 1 passes through P and then comes through at Q. And we want to find the area of the shaded region. And we want it in this particular form, which is helpful to know a bit later on. A and B are constants, so not integers, they're just constants, so keep that in mind too. First thing I notice here is I really want to just divide this into two shapes. If I can divide it into two shapes where one of the shapes is easier to deal with, I really should try and do that if I can. Now, in order to do this, I first will need to work out point P here. Well, notice at point P, this is the y-intercept. So when y is equal to 0, when x is equal to 0, other way around, then we want to work out y. So when x is equal to 0, then y equals, let's pop it in here. So we get 12 on the top, these disappear, we get 10 here, and we can simplify that down to 6 over 5. So we've now worked out that the other way around, so we've got 0 here, and then our y-intercept is 6 over 5. Now notice this line has a gradient of 1. So if this is 6 over 5, well this is then going to have to be minus 6 over 5, 0. So at a 45-degree angle. So a nice little trick you can do here rather than actually writing out, for example, this would be the longer way of doing it, y equals x plus 6 over 5, and then substitute in. What we can do here, because we've got a gradient of 1, we can then just flip the x and y and change this to a minus. So that's making things a little bit easier here because we can work out the area of this triangle. Notice this is perpendicular at 90 degrees, So to work out the area of the triangle, all we need to do is half base times height. So we need to do a half times the base, well that's 6 over 5, and then times the height, which is also 6 over 5. And if we simplify this down, so we can do a little bit of simplifying, we then get 18 over 25. So I'm going to pop that on the next slide here, that the area of the triangle, because we're going to need that right at the end, is equal to 18 over 25. So we've done the hard part there. Well, the easy part there. We're going to go on to the hard part now. So we're going to work out this part here. Well, notice this is at 0 here. We've got our limits essentially between 0 and 2, and we have what we want to integrate. So essentially to work out the area of, let's give this a letter, let's call this B. Then what we need to do is work out the integral between 0 and 2 of that very horrible looking function. However, we have done some hard work on this already in the first part of the question. Remember, with respect to x, is we wrote this as two separate fractions. So what we can do is substitute that in. So we're going to write this as 1 over x plus 1. And they always give you clues in terms of how they want you to solve the problem. So do pay attention to those clues with respect to x. Now this is where we have to be careful with our integrating. The first part is fairly simple because the derivative of the bottom here is just 1. So that's not going to really change anything. So when we integrate this, we're going to get the natural log of x plus 1. Again, the way you can check this is, if I differentiated this, well, the differential of this would be 1 on top, and then x plus 1 at the bottom. This we have to be a little bit careful of, because we've got a 3x plus 10, and the derivative of that is 3. Now imagine we didn't really realise that, and we just wanted to put down, well, we've got a 2 at the top, so imagine you put down 2 natural log of 3x plus 10. This is the wrong answer, but imagine you just put this down, like so. Again, what you can do is check by integrating and see if you get the right answer. Well, sorry, by differentiating and getting the right answer. Imagine I differentiate 2 natural log of 3x plus 10. Then the derivative of this, well, it would be the derivative of the bracket, which is 3, times it by 2 is equal to 6, and then whatever's in the bracket underneath. Now that's not quite what we want, because we have a 6 over 3x plus 10, but we wanted a 2 over 3x plus 10. So what do we have to do to go from 6 to 2? Well, we divide by 3, so I can change the 2 here, and change that to just, 2 over 3. Now let's pop this back in and see if that changes anything. So I'm going to rub out the 2 here, and I'm going to put a 2/3. This is what's going through my mind when I'm doing integration by recognition. If I differentiate this, well, 3 times 2 over 3 is equal to 2, and then the bottom stays the same because I haven't changed what's inside the bracket. I have got what I wanted. So this recognition approach really saves you a lot of time, rather than having to do some substitution and working your way through instead. Right, now we've integrated it, now we're going to substitute in our limits. So let's pop in 2 first of all. That's going to give us the natural log of 3 plus 2/3. Natural log, 3 times 2 is 6, plus 10 is 16. And then we're going to minus when we put in 0. Well, the natural log of 1, I'll write it in anyway. That's going to be equal to 0, so that will disappear. And then we've got a plus 2/3 natural log of 10. Okay, so we've got that in so far. Notice this is just 0, so that disappears. So then we get natural log of 3 plus 2/3 natural log of 16 minus 2/3 natural log of 10. Now, if we go back to what we actually need it written in, we need it written in the form 2/3 natural log of something in the bracket. At the moment, we've got 2 terms in terms of 2/3, but not this one over here, the natural log of 3. So what we'd really like to do here is change the natural log of 3 into something with 2/3 at the front. Let's just call this x for the time being. So I really want it in this form. Now what we can do is actually solve for x here. And the way we can do this is use some of our log laws. So we're going to bring this to the back. So we get the natural log of x to the power of 2/3. And if two natural logs are the same, then these two must also be the same. So we get 3 is equal to x to the power of 2/3. And now I want to get x the subject here. So what I can do to both sides is raise both sides to the power of 3/2. So let me just write that down nice and clearly. Now why do I want to do this? Well, the left hand side is clear. On this side, however, what we get is x to the power of 2/3 to the power of 3/2. The reason of doing this is that 2/3 times 3/2, they cancel to give me just x, which is what I wanted, and then we get 3 to the power of 3/2. Now we can rewrite this slightly as the square root of 3 all cubed. And again, we can simplify this further. You're probably wondering why I'm doing this, but you'll see it later on. This is the same as the square root of 3 times the square root of 3 times the square root of 3. Remember, the square root of 3 times the square root of 3 is just 3, so we get 3√3 as x. So I can rewrite the natural log of 3 as 2/3 natural log of 3√3. So all I'm going to do at this next step is just replace the first term with what we've just worked out, which is 2/3 natural log of 3√3. So why is one of the tricky questions on the exam? Now we've got it in this particular form, it makes it very easy to collect up all these terms. First of all, if we're minusing, it's the same as dividing. So we'll do this in 2 steps. You don't have to. So I'm going to leave this alone for the time being, and then we can combine these 2 terms together. So 16/10. And now we can combine these together. So we get 2/3 natural log. Remember, adding logs is the same as multiplying. So 16 times 3√3 is 48√3/10. And now we can simplify this slightly. So 2/3 natural log of 24√3/5. So we've eventually worked out the exact value of area B. So our final answer, we're going to bring the 2 parts together. So what we did right at the start, 18/25, and what we've worked out. So our final answer is 18/25 plus 2/3 natural log of 24√3/5. Notice they're all constants, so we have fitted the description of the answer, and we've got, most excitingly, all 9 marks. Again, you can check the mark scheme here, so you can have a look. You've got exactly the answer here, or equivalent, of course. We've got exactly the answer that they want. So, hope you found that question really, really interesting, because those 9 markers, it's very hard sometimes to know exactly where to start with it. And again, this gives you a good snapshot of the skills you need for Add Maths. And number 8 here is graph sketching. Although usually a very small topic and it comes up towards the start of the paper, you don't want to miss out on these really easy marks. Okay, and on to graph sketching. This is a small section of this video, but very important to pick up those easy marks at the start. And again, I'm going to go through 2 fairly straightforward questions here. So we've got a graph which is a cubic polynomial. So as soon as you say cubic, you notice it's going to be with x cubed in some way, and we need to find what the function is. Well, notice we've got 3 of the roots here. So we've got -5, we've got -1, and 2. So we know the function has the form of some constant a. We don't know what that's going to be yet anyway, but we do know all the factors. So we do know that x plus 5 will be a factor. We know that x plus 1 will be a factor, and lastly x minus 2 will be a factor. Imagine we solve this, then either x plus 5 is 0, x is minus 5, x plus 1 is 0, x is minus 1, or x minus 2 is 0, and then x is 2. However, we don't know the stretch, like the vertical stretch outside A, but this is where we use our last bit of information here, which is the 5. So when x is equal to 0, y is equal to 5. That's that coordinate I've just labelled up here. And we pop that in to work out a. So we get 5 is equal to a, 5 times 1 times minus 2. That then leads us to the equation, well, 5 times 1 times minus 2 is minus 10a, and that's equal to 5. Therefore, a is equal to 5 over minus 10, which is the same as minus a half. So our final answer here, let me just write it over here, is a is minus a half, so we get minus a half, x plus 5, x plus 1. And you do a very similar process of quadratics also in section 2. And now we need to work out the values of x such that the function f of x is less than 0. Well, we're looking for basically below the x-axis. So we want this part of the graph that I'm just shading in here because we're below the x-axis. But don't forget also over here, we also need this part. So we've got between minus 5 and minus 1. Notice the strict inequality here. So we need to write this clearly. So minus 5 is less than x, where x is less than minus 1. Again, you can write these out separately if you wish, but also that x must be greater than 2, because it also dips below as well. So make sure you've got both parts of that inequality, the 2 marks. The first part between minus 5 and minus 1, and also greater than 2. And you can check the answers very quickly there, again working in a similar way to what I've done. Okay, and on to question 2, where we're going to do a bit of graph sketching here. So notice we've got a modulus function, and that means there's going to be some kind of bouncing effect. So this is what I like to call it, some kind of bouncing effect from the x-axis, because the function can never be negative. So it's going to be bouncing in the x-axis, and what we're going to do here is actually just consider the y equals 4 minus 3x. Imagine we actually tried to plot that line. Well, it goes through at 4, so that's important here. It's going to have a negative gradient, so it's going to go down this way. So we can actually work out where it's going to cross the x-axis by setting y to 0. So when y is 0, we can work this out very quickly, that 4 minus 3x equals 0. So 4 is equal to 3x. Therefore, x is equal to 4 over 3. So we know it's going to go through at 4 over 3. So this is our standard straight line, but we know there's going to be a bouncing effect. So it's actually going to bounce over here. Now, the great thing about this question is we've kind of already solved it. We don't need to do anything with the right-hand side here because we've worked out where it crosses the y-axis and also crosses the x-axis as well. And at this point, they want you to solve this inequality. 4 minus 3x is greater than or equal to 7. The way I approach this, I do this in 2 steps. Imagine there isn't a modulus sign there, and we solve it normally. So 4 minus 3x is greater than or equal to 7. Therefore, minus 3x is greater than or equal to 3. We minus 4 from both sides. Now, when we divide by minus 3, we need to be really, really careful here at this step. So dividing by minus 3 on both sides, because we have to flip the inequality as well. So if we do that, this gives x. We flip the inequality. That's really, really important. And then 3 divided by minus 3 is minus 1. So that's the first answer. But to work out the second answer here, what we're just going to do is exactly the same procedure, but we just put a minus in front of the function because it turns it positive. So by doing this, we then get minus 4 plus 3x is greater than or equal to 7. So therefore, 3x is greater than or equal to 11. And that leads through to our second answer of x is greater than equal to 11 over 3. Making sure we're careful with that inequality symbol. Notice we didn't multiply or divide by a negative number, therefore it stays as it is. And again, you could actually work this out if you wanted to from the graph by actually drawing a straight line. So we're going through at 4, say we go up to 7 here, then imagine we've got this. Notice we'll have 2 answers, and we want greater than 7, so it'd be this part of the answer here, and then this part of the answer here. So again, that's a visual representation of what we're looking for too. Important topic. Make sure you are aware of it. There's the mark scheme there for you, as it does come up very, very regularly. That's why it's in this particular video, but you don't really want to lose these 5 marks when they're there for the taking. And number 9 is radian measure. So we've been using radians in other parts of this video, but we're going to focus on these geometric interpretations using that area of a sector, using the arc length, and using that in terms of radians to solve more complicated problems. Okay, and on to our section on radian measure. I picked out 2 really nice questions here, really exploiting the 2 formulae you need to know when you're working with arcs and sectors with radians. So remember, arc is just equal to r theta, and the area of a sector is equal to half r squared theta. We're going to be using this a lot, and you need to know these formulae in order to access these questions. So we have a diagram. It shows a circle, centre O, radius 2a, and the points A and B line the circumference of the circle. C and D are midpoints, so these 2 points here, of OB and OA respectively, and the arc DC is part of a circle centre O, and the chord AB going across is of length 2a, and we need to work at angle AOB. Now, first thing I notice here, it's out of 1 mark, so it should be something fairly straightforward. Notice if we take the this length here, this is equal to 2a, a plus a is 2a. This here is also equal to 2a, because they're both radii of the circle, and we've got the chord that's also equal to 2a. So we have an equilateral triangle here because all sides are the same, therefore all angles must be the same, and so this angle here is equal to 60 degrees, but again we're working in radians here, so remember 60 degrees is the same as pi over 3 radians. It's really useful, as you've seen in other parts of this video, to know these exact values very, very quickly. So the angle AOB is just equal to pi over 3 radians. Now it gets a bit tricky, and this is typical on both the questions you're going to see today, which is where we're going to work out the perimeter and area of various shaded regions. And this one is a bit trickier because we need to do it in terms of A and pi, so we don't have much numbers to work with here. So if we want to work out the perimeter of this shape, let me do this in green here. So we'll need to work out this arc length. We already know these 2 lengths, the ones I'm doing in green here. These are both equal to A. And of course, we already know the chord length, which is equal to 2A. So essentially, what we need to work out here is the perimeter is going to equal, well, 2A plus A is 4A, plus the arc length of CD. Well, let's have a think about this. How do we work out the arc length of CD? Well, the radius of this particular sector is equal to A, so we can just use the formula over here, r times theta. Now, we worked out theta before. This angle here is pi over 3, so all we need to do here is just do 4A plus pi over 3 times then A, which we could write slightly more neatly here as 4A plus pi A over 3. So again, 2 mark question, not going to expect you to do too much here, but just make sure you're nice and precise as you're writing down the answer. Now this one, 3 marks, that's going to be a little bit more work, is now the area of the shaded region. Well, let's go back to work this out. Well, the approach that we're going to take here, let me go back to my red pen here, is if we work out the area of the triangle and then take away the area of the white sector here, we'll then get the area of the grey. So I'm going to write that down here. So the area of shaded is equal to area of the triangle, so nice and clear, minus the area of the white sector. Okay, so let's work our way through. Now the area of a triangle, you need to know that formula as well, and that's equal to 1/2 AB sine C. Again, it doesn't matter if C is in radians or degrees, as long as you can work it out correctly. Well, let's have a look. Our A and B are going to be the 2A lengths. Remember, taking the entire triangle here. And then we want sine of the angle in between, which is sine pi over 3. So if we pop this into our formula, we get 1/2 times 2A times 2A times sine of the angle, which is pi over 3. And then the area of the white sector, we can just use this formula that we wrote down, 1/2 r squared theta, where our radius is a and the angle hasn't changed. So we then get minus a half a squared times just the angle here, which is equal to pi over 3. This case is just a case of doing a bit of simplifying and tidying up. Notice a half and the 2 cancel here, so that's helpful. So we get 2a squared. Now you should know what sine pi over 3 is. You can check on your calculator. You need to know these exact values, they do help. This is equal to root 3 over 2. Here, of course, we get, what, a half times pi over 3, so we get 6 on the bottom. So we're going to get pi a squared on the top, 6 on the bottom. And we could do a little bit of final cancelling here because the 2's cancel. That's why exact values are great to work with. So we're going to get root 3a squared minus pi a squared over 6. Okay, so we get our final answer, looking nice and neat. Notice they've written it exactly the same way as I have here, so that's very nice. Notice you get a lot of follow-through marks for this kind of question. So say you got the angle wrong for whatever reason, you thought it was pi over 4, then you're going to get a lot of method marks as you go through, these so-called follow-through marks. So don't feel like you're always going to get punished on these questions for getting a part wrong. They are going to help you as you go through the question for B and C. Right, on to probably a more typical radian measure question on Add Maths, which is when they give you some numbers and you might need to use a little bit of trigonometry here to help you work out bits and pieces. So DAB is a sector of a circle and radius is 18 centimeters. CB and CD are tangents to the circle. That's important because if this is a right angle, then this has to be a right angle as well. And angle DAB is 7 pi over 9 radians. Notice we actually got a kite here. And one of the special things about a kite is if you take this entire angle here, these two angles have to add up to 180 degrees or pi radians. So we want 7 pi over 9 plus something, and that's equal to just pi radians or 9 pi over 9 radians. That means then this angle here must equal 2 pi over 9 radians. Therefore, one of these angles, which is what we're going to focus on here, is equal to just pi over 9 radians. That's really important as we go through this question. So I'm going to put that in. Now we need to work out the perimeter of the shaded regions. So first of all, we're going to have to work out this arc length using the formula we've seen before. And then we're going to have to work out what BC and CD are. So the perimeter is going to equal the arc length. Now we could do that straight away because we know the formula from before. Arc is equal to, I'll write it in here again, r theta. So that's equal to the radius, which is 18, and then times 7 pi over 9. So just doing radius times the angle. And then we also need to add in what BC and CD are. Well, notice we've actually got a right angle triangle here. So we've got, if I just draw this out separately, right angle here, we're looking for BC, so we're looking for this side. We know this is 18, and we know this angle now because of the kite rules and circle theorems, pi over 9. So we can use basic SOHCAHTOA here to work this out. Notice that tan of pi over 9 is equal to opposite over adjacent, so 18 over x. Therefore, we can just do a little bit of rearrangement here. So x is equal to 18 over tan pi over 9. And if we put this back into our formula, because notice BC and CD are exactly the same, we then get 18 times 7 pi over 9 plus 2 lots of what we just worked out, 18 and tan pi over 9. Really don't rush to your calculator until you've got it literally in this form ready to work out, which is what we're going to do now. Okay, so make sure your calculator is in radians, otherwise bad things are going to happen. So let's pop it all in. So the first part of it was 18 times, okay, open fraction, 7 pi over 9 plus 2 lots of, and we want a fraction here, 18 over Just another reminder for you, put it in radians, it's important. And then control divide pi. Again, a little bit awkward, but just make sure you're taking your time, making sure to put brackets in the right place, which I am hurriedly putting in. Then press the big enter button. And we get the exact value, which is not so helpful because we want it as a decimal. So there we are. We get our answer, 142.891. So 142.891. Always rounded to 3SF here. So we're going to have 143 centimeters, then to 3 significant figures. Make sure you put in, first of all, the rounding that you've done and also the correct units. We are working in centimeters. Right, on to the second part of this question, which is now very typical, the area of the shaded region. So let's think of our strategy first of all, how we want to work out the area of total. Well, we want to work out the area of the entire kite here, and then take away the area of the white sector. So I'm going to write this down, area of kite minus area of white sector, like so. Now you don't actually need to work out the area of a kite or know the formula. Notice we've divided this into two triangles anyway. So all we need to do is work out the area of the two triangles. We now know this length here. This is equal to 18 over tan pi over 9. So to work out the area of the entire kite, we do a half base times height. So 18 times 18 over tan pi over 9 divided by 2. But then we're going to times by 2 because we've got two triangles. So in fact the area is just going to be 18 times 18 over tan pi over 9. And now the area of the white sector, again that really important formula, I'll pop it down here. The area is equal to half r squared theta in radians. So we have half times 18 squared times 7 pi over 9. So half times 18 squared times 7 pi over 9. Only at this stage would I now put this into my calculator. Okay, so let's just take our time here. So we've got 18 times, don't really need to put the times in, 18 over tan and then pi over 9 brackets minus now the area of the sector, so 0.5 times 18 squared times fraction again. Well done if you made it to this part of the video. I know there's a lot to cover on Add Maths, and try to give you the very best help that I can give you. We'll press the enter button and then we get 494.342. 494.342. Again, rounded to 3 significant figures, 494 square centimeters to 3 SF, just like that. And you can check all the answers that I've just been doing here. Get a very standard question using area and perimeter formulae from radians and using that in a practical context. And notice they can fit in other topics in there as well. They've put a little bit of trigonometry in here for good measure. So that's the end of the radian measure section. So I'm just going to go through the conclusions now to this particular video. So I hope you really enjoyed the content. If you want more content like this, then please do like and subscribe to the channel. That really lets me know exactly what you are interested in. If you'd like extra to this particular content, then let me know in the description below so we can work on more Add Maths content together. And if you really want to practice what we've learned in this video in exam context by going through a past paper, then do check out the video right here.